not playing. Hey, no. No, it loaded, but it's not playing. Yes, leave it, leave the video. You show the thing. Yeah. He's calling. We'll manage. Yeah, yeah. Chalo, chalo. Mm-hmm. Leave it, sir. Do you think we're good? Okay, good morning for day two. We have 2 minutes to get started for the day two. Thank you for being here for day two. Again, my name is Prakash Ranganathan. I'm a founder for the CARS conference and also the director for cybersecurity at UND. Today we have another full day packed with the hands-on workshop with AWS. And in the afternoon, maybe during the lunchtime, we also have a quick 30-minute talk from Microsoft on Zero Trust. So stay tuned for that and make the best use of this workshop. Participants who complete the workshop will receive a certificate, so that you know that your time is and everything is appreciated here, and maybe you will learn something useful from this workshop. I want to introduce and recognize a few people here who have been very supportive. First, Lucas Metzger from AWS. They have been a very asset to us. They have, Lucas brought a big team to UND. Thank you, Lucas, for being so generous to bring your team and help us to do this workshop. Also, we have three other folks from AWS. I will introduce those speakers shortly. Darren Roebuck, and Kai Dickman, and Archit Malpore, and Varun is also here from AWS. So let me give us, these are the three speakers who's going to going to spend time with you all day today on these two different workshops. Let me start with Darren Roebuck. Darren Roebuck is Senior Solution Architect, AWS. Based in St. Louis, Missouri. He has 20 years of experience in IT and is passionate about data analytics, generative AI, Internet of Things, and security and compliance at AWS. Darren partners with energy and utility customers to help them solve business challenges with AWS technology. Outside of work, he enjoys woodworking and spending time with his family. Kai Dickman is a senior AI and machine learning specialist, AWS, and supporting public sector customers with over 25 years of experience spanning on-premises and cloud technologies. Kai works with both executive stakeholders and technical teams, architecting scalable machine learning solutions and implementing responsible AI best practices. In addition to a passion for all things AI, Kai enjoys connecting the real world to the cloud with IoT. And then we have Archit Malpore, Solutions Architect with AWS, supporting state and local government and higher education. With 5 years of AWS experience, he specializes as a cloud infrastructure generalist who works backwards from customer business outcomes. Archit focuses on designing and delivering solutions that align with the unique requirements of public sector organization, helping them implement AWS best practices to achieve their strategic goals. Thank you, AWS team. You've been awesome and being here today. I hope you're enjoying the UND visit. And also thank you for all the sponsors here, Minn Kota Power, Northwestern Energy, UND Center for Innovation, Microsoft, all my support staff at C2SR. Thank you for making sure this event is actually going good, and thank you to our conference co-chairs who is also here from everywhere, and so I appreciate for you being here to support this event. With that, I want to invite Lucas to come forward to say something about AWS, what they do, and then we can kickstart this event.
Hi, everybody. Great to meet you all. My name is Lucas Metzger. I'm the account manager here for University of North Dakota, but my entire focus is in how we at AWS support higher education. Now, of course, I think you all are focused in the research space. That is one of our strongest areas in which we at AWS invest time and resources to help you all get to time to science quicker, more effectively with all the resources that we bring to the table. But on top of that, we also work with all of our higher education customers in terms of modernizing their infrastructure, migrations, and move from on-premise technology into the cloud, and of course, really creating a better student experience from chatbots to communication strategies and really engaging with the students as well. But again, I think our strongest area and largest focus at AWS is the research workload. So we've been working hand in hand with Prakesh and his team, helping them develop solutions, working through their architecture, and we're also spending time with the HPC team here at UND in terms of moving some workloads into the cloud with AWS. But these are just a few specific areas that we spend our time with, but I'm really, really excited for the two opportunities or the two workshops that we're presenting today. Kai and Darren are both extreme specialists and have run through these workshops before, so we're happy to take you through this. Again, keep this as interactive as possible. I'm sure Darren will say the same thing when he's working through that presentation, but we have a group of folks here in the back that are all happy to support. Make sure you guys get what you need as we work through these programs. But again, we also have some merchandise at the back. If you guys want some AWS content and materials back there for you, and then as well as my cards and information if you need to contact AWS on any workloads or anything you guys want to dig into. But again, Prakesh, thank you so much for having us here today, and we're really excited for the workshops. Thank you.
And some logistics, and do you want them in the first two rows because we have power cables there?
I think that makes sense.
There are power cables in the first two rows so that you can connect your laptops. There's no disruptions to your bookshop. So if you want to come forward and use the power cables in those tables, it will be much appreciated so that you make sure that your laptop doesn't turn off. So, okay. So this side there are 4 tables that is free, and please come forward and make use of these upfront tables. And I also want to recognize our UIT, University of IT team has been very supportive whatever we do. I think, thank you, Ethan and Madhavi and then their team has been very awesome. And thank you again for Memorial Union staff for again being very supportive for this event. It's also streamed online. Hopefully people are also going to listen to online. So with that, I don't know how you guys can kickstart.
Catch. Well, that was nice. Thank you. Thank you. You're welcome. I don't need to join the Zoom, do I? Yeah. Gentleman here looks like he may have an answer. Do we need to join the Zoom meeting? Do you need us to join the Zoom meeting? Is there anybody online? Okay. Okay, cool. I'm sorry? I haven't connected it yet. We did test it and it worked earlier. The email. Good morning. How's everyone? Awesome. Thank you for letting us come in today. We're excited to talk to you about AWS IoT. I am Darren Roback. I think we did the intros, so this is Archie.
I'm Archit Malpure. I'm a solutions architect at AWS, and yeah, nice to meet you all.
So we're going to run through an AWS IoT workshop. So part of what I do, I support regulated utilities at AWS. I'm part of our IoT solution architect community here at AWS. I've been at AWS for 4 years. I spent a lot of time working on IoT solutions. And so what I thought we would do today is run through kind of a brief presentation on what AWS IoT is, what are some of the different components there. We'll be super quick with this, and then we'll get into the actual workshop. And so this will make more sense as we go through the presentation, but we have a couple of different offerings within the IoT space. Our workshop's primarily going to be focused on an open source or a software-based runtime called AWS IoT Greengrass. And we're going to walk through setting that up in a virtual environment. We'll get all of you guys into a lab environment, and we'll go through it together. And as Lucas mentioned, definitely want to make sure that this is interactive. At the end of the day, this is all about you, and we want to make sure that you're learning about AWS IoT and getting all of your questions answered. So, with that.
Feel free to raise your hands, and if you have a whole team, we can come in and labs.
Absolutely. So this is our agenda for today. So I'm going to talk a little bit about AWS IoT and what that ecosystem looks like. Talk about some of the unique customer challenges that AWS IoT solves for. Then I'm going to dive a little bit deeper into AWS IoT Greengrass. We'll get everybody access into the workshop environment. And then I've got some materials I wanted to share, some links to GitHub repos. We've got some learning, if you're interested in diving a little bit deeper into AWS IoT, and then also want to hear your thoughts. So we've got a survey prepared for you today as well. All right, so I'll dive right in. So the market for IoT devices is exploding. And think about how many IoT devices you have in your house. Probably have Alexas, smart thermostats, smart light bulbs, smart switches. All of these things are using a variety of different protocols, and they're all communicating sometimes with each other, sometimes to cloud services. And so the need for device manufacturers to be able to manage, monitor, and maintain a fleet potentially of millions of devices, it is pretty difficult to do. When I first started at AWS, I supported a smart device or a smart thermostat manufacturer. And they had over 10 million smart thermostats deployed globally, and they used AWS IoT to manage those devices. And so that's really kind of one of the main value propositions behind AWS IoT is that we want to make it easy for customers to deploy software to devices, manage those devices securely, and enable them to exchange data with the cloud. So some examples of what customers are doing with AWS IoT. I work a lot with the energy and utility sector. That's my primary customer base. I see a lot of customers ingesting data from smart electric, gas, and water meters within customer premises. I see a lot of renewables deployment. So if you think solar panels and big wind farm fleets that are out there, all of these are collecting data and they're sending those back to the utility on things like photovoltaics, sun density, wind speed, direction, things of that nature, and customers are using these to control these devices. I've also spent a little bit of time working in the healthcare industry. One of the projects that I had built shortly after I started at AWS was a seizure detection device that would built on top of Greengrass that would stream in heart rate and movement data to detect seizures while people were sleeping. So there's a lot of different use cases across a variety of different industries, but the core theme remains that we need the ability to manage these devices at scale. So that's what AWS IoT is all about. Okay, so how do we do that? How do we make sense of my AWS IoT data and enable these devices to take action? How do I control, manage, and deploy device fleets at scale? And then ultimately, how can I build and operate devices that run at the edge? Oftentimes, and again, if you think about your Alexa device at home, this is a device that is capable of controlling other smart devices within your residence, and so it needs the ability to communicate with devices over a variety of different protocols on your local network. And so when I talk about AWS IoT, I generally refer to it as a three-legged stool. And what I mean by that is we have device software, we have our connectivity and control services, and then we have our analytics and streaming services. At the end of the day, it's really all about data, right? And so I'll maybe kind of talk a little bit about each one of these pillars. So on the device software side, we have a couple of different options, and I'll go into these in a little bit more detail, depending on what the customer wants to do. So we support a free RTOS, which is an open source software operating system for microcontroller-based devices. We've developed a solution called AWS IoT Express Link, which is a combination of hardware and software that make it easier for partners to develop devices that connect to AWS IoT. Greengrass is a software-based runtime, and that's what we're going to be doing our workshop on today. So think of Greengrass as being able to be installed on any device in any OS, and you'll be able to instrument that device to connect to AWS IoT. And then we also have the AWS IoT Device SDK. So if you want to kind of build your own solution and manage your own software, and you want to connect that solution into AWS, we make an SDK for that as well. On the cloud side, in terms of connectivity and control services, so IoT Core, we're going to spend a ton of time in today. IoT Core is our main landing point for all IoT devices that are operating out in the field. And then we've got some functionality that we've kind of built on top of IoT Core. So device management, obviously a core capability of IoT Core. We also have Device Defender, which helps us secure and monitor devices that are running in the field for anomalistic behavior. When we talk about connected vehicle fleets, we have a software solution called FleetWise that helps customers manage those. So think about all of the Teslas that are out there and smart vehicles that are out there that have these microprocessors that are running on them. So FleetWise is a service that they take advantage of. And then RoboRunner is another specialty service. So if you think about, there's been a lot of news lately about Amazon and our use of intelligent industrial robots. RoboRunner is a service that we make available for customers to manage fleets of their own robotic solutions. And then also within the cloud, just touching very briefly on analytics and streaming services. SiteWise is a service that customers can use. We see it a lot in manufacturing and energy and utilities. And really what it is a solution that customers can use to connect historian data on premises to the AWS cloud, and they can use it to model assets and obviously ingest data and detect anomalies and run predictive machine learning models. TwinMaker is a service that enables customers to create digital twins based on IoT solutions. And then KVS, as we call it, or Kinesis Video Streams, is just a mechanism to ingest video and audio in real time into the AWS cloud. So just a little bit, obviously I kind of went through that. There's not going to be a test at the end of this. Gives you a little bit of an idea of the breadth of AWS IoT services. So there are 4 common challenges when we connect IoT devices or when we think about fleets of IoT devices. Number 1 is security. How do I ensure that the devices that are out in the field are not only secure from local tampering and local data exfiltration, but that they're also communicating and authenticating to the cloud in a secure manner? We also have challenges around device deployment. If you think about Alexa as an example, how many people in here have an Alexa at home? I know I do. What was the experience when you unpackaged that Alexa and you plugged it into your network? Pretty seamless, right? Well, that's really what we're talking about with device deployment. When these devices are manufactured, we want to pre-stage them, and we're going to run through this today in the workshop as well, so that they can immediately connect with AWS IoT and provision themselves in a manner very similar to Alexa. We also want to make the process to deploy and run software solutions on those devices easier. We're going to spend a lot of time in the workshop today talking about component definitions with IoT Greengrass. And a component is just a way for us to build some modular software application that we can orchestrate at scale and deploy to thousands or millions of devices that run in the field. We'll get into all of that in the workshop. And then lastly, we want to make it easy to manage these devices. So things like collecting telemetry data on the devices, remotely connecting to the devices if you have some sort of a problem. Again, managing the software applications that run on these devices. These are all things that we want to be able to solve for. So I mentioned earlier, I gave some examples of the device software pillar, that 3-legged stool metaphor that I used. And so this can be kind of a confusing point. And usually I like to tell customers to think about it in terms of microcontrollers and microprocessors. Microcontroller is just a purpose-built device, a smart thermostat, a connected light switch, something that really doesn't have a lot of intelligence behind it. Typically, it's running an embedded operating system, such as FreeRTOS, and we can connect those devices to the cloud. On the other side is our microprocessor-based solutions. This is where an Alexa would come in, or a Sonos smart speaker, or a Fire TV as an example. These are devices that typically have a little bit more horsepower under the hood. They can run commercially available operating systems such as Microsoft Windows or Linux, and we can build software-based runtime, which is IoT Greengrass, and we can connect those into AWS IoT as well. And then lastly is the ExpressLink module. This is just a purpose-built hardware module with software pre-installed on it. It makes it easy for other partners that are out there that are building their own hardware solutions. So with Greengrass, we have a couple of different options. So I'm going to kind of pivot into talking a little bit more specifically about Greengrass. Option number 1 would be a device that runs Greengrass and communicates directly to the cloud itself. So it is the one that has some sensors, maybe smart light switches, or let's stick with our Alexa example here. There's really no other devices on the local network that it's communicating with. This is the IoT device, and so we want to enable communication to the cloud. The other option is a hub-based deployment. So Greengrass, one of the capabilities that it gives you is to communicate across the local network. So if I go back to this kind of seizure detection solution that I was talking about, I had a heart rate monitor, I had a bed pressure monitor that would detect movement in the night. These are all things that are communicating, in my case, using Bluetooth Low Energy to a Greengrass-based device, and Greengrass was then sending that information on behalf of these devices to the cloud. So Greengrass has been purpose-built to solve for the 4 challenges that I mentioned earlier. So when we talk about security, all Greengrass devices authenticate using X509 mutual TLS certificate-based authentication. All Greengrass devices use TLS 1.2 to encrypt their communication to the cloud. And then we also provide support for various different hardware security modules if you want to further lock down those devices. We also have some automations in place for device development. So with Greengrass, we provide you portability across edge devices. So if you develop a component and you want to deploy it across our heterogeneous device fleet, that's something that you can do with Greengrass. We kind of abstract that for you and make it a little bit easier for you to deploy that across a fleet. We also support MQTT, so message queuing and telemetry transport is a very common protocol when we talk about IoT. So we support both MQTT 3.1 and MQTT 5. And this is really what's enabling you to send and receive data to the device from the cloud. And then we also support device management with Greengrass. So fleet provisioning is something that we're going to go through today that automates the provisioning of these devices out in the field. But then we also support device indexing and obviously telemetry capture from the devices as well. So when we talk about Greengrass, AWS, we have somewhere north of about 180 services right now, which can be a little difficult to keep up with, and I work for AWS. Greengrass communicates primarily with AWS IoT Core, and we're going to be working a lot within IoT Core today. But you can also configure Greengrass to communicate to virtually any other AWS service. We're going to explore this a little bit in the workshop today as well. A good example there would be configuring Greengrass to stream log information into CloudWatch, which is something that we're going to do. I'll talk in the workshop a little bit about like how that authentication actually happens. But just know that we kind of open up the entire suite of AWS services to the devices that are running Greengrass in the field. So this is what Greengrass looks like from a software perspective. So it sits on top of the operating system. So we have an installer that will run on top of an OS, and we're going to do this on top of Linux today, specifically Ubuntu. And that installer is just a runtime. We have a single component, so the core of AWS IoT Greengrass is called Nucleus. We're also really good at coming up with service names at AWS. And Nucleus enables us to install other components and communicate with the IoT cloud. We do support portability across hardware, so ARM, x86, operating systems. I mentioned Linux and Microsoft Windows. You can even containerize Greengrass, so if you want to run it in that manner, you can do that as well. So I'm going to talk just quickly about some edge capabilities. We'll get into some management capabilities, and then we'll dive a little bit deeper into the workshop. So local messaging is a feature of Greengrass. Really what this means is the ability for a Greengrass-based device to communicate with other devices on the local network, as well as the ability for various different components running on Greengrass to communicate with each other. We call that inter-process communication, or IPC. If you think, and we're going to do this today in the workshop, I may have a Greengrass device that's running 10 different software components on it. And oftentimes I'm going to need to exchange information between those software components. And so Greengrass gives us that capability for that communication. Greengrass also supports state synchronization. So if I need to operate in semi-connected environments or disconnected environments where I need some ability to persist data locally and have a device that can operate when a cloud connection is severed, that would be a great use case for AWS IoT Greengrass. We don't rely on the AWS cloud being there for that device to function. All of our Greengrass devices also support lifecycle management. So if you think about these little software packages that we're deploying to it, it's really important for us to manage the lifecycle of those applications as well as the lifecycle of those applications as it relates to other components that are running on the device. It's super easy to do. I'm probably making it sound more complex than it really is, but all of that lifecycle management is baked into Greengrass. We can also do things kind of dovetailing into this afternoon's workshop with ML inferencing, so we can deploy models that run at the edge. I see a lot of this in the utility industry, specifically around like load disaggregation. So this would be detecting if someone's plugged an EV in at their home, and maybe then automating the process of sending them a text message to offer them a better time of use rate. And so all of that is driven by an ML model, and increasingly customers are starting to deploy those models at the edge. Stream Manager is just a capability of Greengrass for us to stream data in. We use Stream Manager even as part of our Sitewise offering, which does run on top of Greengrass. So if you have the need for near real-time data in the AWS cloud to take some action on that data, Stream Manager is going to be our primary mechanism to get it in there. And then secrets management. So oftentimes we need the ability to store encrypted secrets for authentication with local devices or even authentication to the AWS cloud. I may have a component that's running on top of Greengrass. I want the ability to store and retrieve a secret, so that management capability is also something that we provide. From an overall management perspective, I've talked a little bit about some of these, but just the fleet management capabilities of Greengrass. So again, millions of devices that are out there in the field. We index all of those devices within AWS IoT, and you can target management operations to wide fleets of these devices. We're going to see today in the workshop how we can manage these remote applications and also perform over-the-air updates to them. So if we need to update either the version of Greengrass or the version of a software component running on top of Greengrass, that's all something that we can orchestrate at scale in the cloud. I already touched on the security capabilities of Greengrass, so maybe I'll just kind of round it out and talk about the local tools. So we do provide a CLI for managing Greengrass, so we'll see this in the workshop today. If you need to maybe deploy a component locally on a Greengrass device and test that, that's something we support. We also support a local debug console, so if you want to deploy a web application on Greengrass to provide some local management capabilities. And then I already mentioned the ability for Greengrass devices to communicate locally on your network to other devices that are out there. So last year at reInvent, I'm going to touch just very quickly on a new entrant to the Greengrass family. We introduced Nucleus Lite. So Greengrass, if you look at the AWS documentation, you're going to see it referred to as Greengrass version 2. Greengrass version 2 runs on top of a Java virtual machine on the local device, whether that's running Linux or running Windows. And the challenge with that is, and I'll relate it back to the customers that I work with. If you think about the smart electric meter on the side of your house, not a lot of compute power on there. The ability to run a JVM on there is pretty restricted. And so we came out with Nucleus Lite specifically to provide Greengrass software capabilities that run on power-constrained devices. We've removed the JVM requirement, runs on top of C, and I'll just skip right to the next slide. And you can kind of see a little bit of a difference there in terms of the overall memory footprint that's required. So Greengrass V2 is going to be our most feature-rich Greengrass offering, but if you are operating on a power-constrained device that has severely limited memory capabilities, Greengrass Lite could be the thing for you. Okay, and this is just a comparison in terms of the differences between our AWS IoT SDK, Greengrass Nucleus, and Greengrass Nucleus Lite. I think, I'm not going to walk through the whole chart. I think the thing that I would leave you with is Greengrass V2, the standard Nucleus, is definitely our most feature-rich product, but again, if you're running on a power-constrained device, the Nucleus Lite may be the thing for you. Okay. So just kind of rounding it out, we want to make it easier for customers to build fleets of devices at scale. We want to make it easy for customers to kind of remove what we call that undifferentiated heavy lifting. So we want to provide that software capability, and our customers can then build on top of it. So that's really what we're talking about with Greengrass. Obviously, we want to make this as secure as possible. So we've baked security into our Greengrass offering. And then we also want to give the devices the ability to operate offline. We recognize that, especially in rural and remote areas, that these devices may have intermittent connectivity. So all capabilities of Greengrass. And then one of the things that I love about Greengrass is that it runs anywhere. I've had customers deploy Greengrass on Intel NUCs running in the field. I've had customers deploy Greengrass on top of AWS Outposts running within their data center. We see Greengrass on cruise ships, on big compute farms. I mean, anywhere you can think about it, we can support it with Greengrass. So with that, I am going to bring you into the workshop. And this is usually the hardest part of the presentation. Actually, how are we doing on time? I think we're pretty good. So I think we're going to take a break at 9:45, yes. I remember right. So maybe our goal would be to get everybody into the workshop, make sure everybody can access it, and that'll probably take us to break. You wanna?
Yeah, that sounds good. Just to introduce myself again, I'm Archit Malpure. I'm a solutions architect at AWS. I specifically support state and local government and higher education customers, and I help customers onboarding on AWS, helping them building solutions, and help talk about best practices on AWS. So I pretty much talk generally about all AWS services, but we have specialists like Darren and Kai who dive deep into the specific AWS services and domains. So today, to get into the workshop, we'll be walking you through how to set up the IoT Greengrass software and on the AWS console and run what Darren described inside. Like we'll be providing you AWS accounts, which are like sandbox accounts and it will have instructions where you can go through the workshop and go do the labs on these sandbox accounts.
Show of hands, how many people have logged into AWS before? Okay, so maybe about half the room. Right.
That's great.
Everybody's going to log in today.
Yeah. We'll be providing these sandbox accounts. I'm not sure if you already have AWS accounts, you can use them, but again, you already know that it comes with a spend, so it's better you use the sandbox accounts that we provide, and they are available for 2 days, so you can even work on these offline. So if you you can join the workshop link by either scanning from your phone or you can navigate, and I'll be walking through how if you navigate through the.
We need to start the event too.
Okay.
And I've got it. I don't know why I'm talking into the mic, but it is starting. Look at that.
Yeah.
Ahead of the game.
Yeah. So we will navigate to this link. Okay. Okay. So if I click on this link. Okay, so we are only sharing a window.
And if you're having any problems, raise your hand and we'll come over too. Perfect. I'm gonna tell this to everybody because everybody's gonna need to know this. When you click on that link, you're gonna be asked to authenticate. And it's going to give you a few different options. I would select the one-time passcode option and put in any email address that you have access to. Yeah, it'll probably take about a minute for that to come in, and you'll get perfect. And then once you've authenticated, you put in that event access code. So you know you're in a good spot when you get to the end and you have to accept the terms and conditions. Read them carefully. I'm just kidding. Perfect. Yeah, you're great. Anybody else having problems getting in?
Yeah, give me a second. I'm connecting my laptop.
Archit, when you reconnect, can you put that event access code back up?
Yeah, sure.
You didn't like my Windows machine?
No, I tried to share the entire screen. If you can help with that.
Sure. You want to take that?
Yeah. So that we can start on the workshop as well.
Yeah. So there's the event access code. I see you out there. I just want to make sure that she gets it.
Okay, we are good.
Good? Okay. And then you want to, let me close out of Slack. Stuff. And then you want to,
Share the entire screen.
okay. All right. And we'll do window. Boom.
Yeah, once you're on the screen, you just accept the terms and conditions when you log in using the event access code. And you will see the screen which says Green Grass Workshop. Is everybody on this screen? Okay.
It should be on there. Perfect. You want to tell them a little bit about
Yeah.
what we're going to be doing?
Yeah. So when you go to the workshop, yeah, sure.
I promise this is the hardest part of this workshop. You are all winners if you can get in.
Show of hands is if everyone has the event access code. Okay. And you will see the screen once you enter the event access code, you will be prompted to agree the terms and conditions, and you will see the screen. So on the left part, you will see the modules. So we'll be going through these modules, and simultaneously when you're working on these workshops, you can refer these modules where you will see the instructions and description of the labs and introduction and the details and walkthrough of the lab. So we'll be using the same steps. So you can follow the steps here as well when you're working on the workshop. So before we log into the AWS accounts, so today we'll be, as Darren introduced about IoT Greengrass, we'll be mostly doing labs with IoT Greengrass. We'll be basically we'll be installing, we'll be creating like a simulated device. We'll be installing the IoT Greengrass software on a VS Code, and we'll be running components on this. Basically, we'll be building an application on the VS Code server. So if you have ever worked with Visual Studio Code, you can like build and run applications there. So we'll be running the Greengrass software over there. And what we'll be doing is we'll have components. So components are like, using IoT Greengrass, you can manage these components and install your applications there. And you can have multiple components. So a component is like a blueprint of your application. It has a configuration file. It has the actual code and script. And then you have, if you have multiple components, you can have dependencies, and you can define those dependencies in the components. So we'll be doing all that in the workshop. And looking at the architecture, this is what we'll be deploying. We'll have the VS Code server environment where we'll have we'll build the components, and we will also be creating custom components. And we'll be having like communications using MQTT between the devices, and we'll be deploying those components by the Greengrass Cloud Service and IoT Core managed in the AWS cloud.
I'm going to just add one thing about components real quick. So on this diagram, you'll notice two boxes, AWS provided components and custom components. So we actually have three different options when developing components for Greengrass. We make components that you can use, and we have a whole catalog of those, and we're going to see those today. We also have community components. So others out in industry have built components for common use cases. We have a GitHub repo that describes all of these community components. We also surface these community components inside the AWS IoT console. And then we also provide customers the ability to develop their own components from scratch. These components, and we're going to see them today, and Archit just mentioned it down at this custom components box, we're going to develop some Python scripts. And we're just going to deploy those to IoT devices. We're not going to test you on coding. We're going to provide the actual code for it, right? But it's super easy for us to build and deploy these.
Yeah, so now we'll be diving into the AWS account, which is provided by the workshop. We will be working mostly in the US East 1 region. That's right? US East 1?
Yep,
Okay.
US East 1.
Yeah. So to log into the AWS account, on the left panel, you see, when you see the screen, there's an Open AWS Console button. So I'll suggest that you open this in a new tab. You click on it, and it opens an AWS console. And you'll see if you're familiar with AWS, you'll see this home screen with the like the applications, cost and usage. And at the top right, you will see you are in the North Virginia region, where we'll be deploying our IoT workloads. So is everybody, oh, I'm getting some feedback. Is everybody on this screen? Are you able to open the AWS console? That's cool. So I'll be toggling between tabs just to, so you'll probably be doing that as well when you follow the instructions. And we'll start with deploying the VS Code server, which will be in an AWS virtual machine, which we call EC2 instances. And we'll be deploying the Visual Studio Code server on the EC2 instance. And once we deploy the Visual Code server, a Visual Code Studio Code server, we'll be running commands on the AWS CLI. So CLI will be the AWS's command line interface. So on your VS Code terminal, you will install the AWS CLI, and it's where we'll be running the installations and commands to to deploy and run these components and IoT Greengrass.
So this is kind of a confusing part about the workshop that I just want to clarify. So we have deployed an EC2 instance in AWS. We have installed Visual Studio Code on top of that instance. That instance is going to be our IoT device. We're actually going to create multiple instances. We're going to actually create Docker containers and we're going to run them locally. So VS Code is our IoT device in this case.
Yeah, that's correct. We are basically simulating an IoT device on an EC2 instance. So we'll start with the VS Code deployment. So to deploy these EC2 instances, instead of manually creating everything, we have CloudFormation stack templates. So CloudFormation stacks are basically through a template, you can define a set of services, and then you can automatically deploy those services. So we have already provided you those stacks, and you will be just be deploying those stacks. So just click on the US East one CloudFormation stack in the instructions.
Archit, I'm sorry to interrupt you. We have some people that are still missing the code.
Where are we at? The access code?
I don't want to out them. But if you could just flash it.
Oh, you don't get swag if you don't have the access code here. No, I'm just...
All right, I'm going to take a picture of this. Hang on.
Oh, it's not bright enough?
All right, Archit, I think we're good. It's called Nightlight.
Huh?
Nightlight.
What was it? So you can't control the display from here. Yeah, they're saying it's not bright enough.
Yeah, it's kind of dim. So, Nightlight.
Oh, okay. That's better. So once we are in the lab 2, let's begin. We are creating a VS Code server environment. We'll click on the launch CloudFormation stack. Once you're logged into the AWS console, we'll click on the launch CloudFormation stack in US East 1. And you will see the following options. It will ask for a stack name. So you just copy the stack name, for example, or you can put your own name. So we'll say VS Code server stack. And we'll define a VPC. So VPC, if you have deployed any AWS instances, VPC is where it's your dedicated network environment where you will be deploying your AWS services. So it's like an isolated network environment on the cloud. So we will define, if you click on the VPC, you will already see a drop down, the VPC ID. Then we'll select the subnet in which we want the service. So subnet, we'll be selecting this one, 172.31.0.0/20. The last one. And instance type, basically what type of compute do we need for this environment. So we'll be using the default one, keep it as default, and we'll leave the key pair untouched. So everything as default. So key pair will be used to log into the environment. I think everything needs to be the default. So we can keep everything as default and then scroll down and say, I acknowledge that AWS CloudFormation might create IAM resources. So we click on create stack. So let me know everybody has been able to create the stack. So this will be deploying the AWS resources that we need for these labs. Yeah, so the stack will take like 10 minutes to deploy while it deploys all the AWS services. You can track it using like clicking on the refresh on the right. But while we do that, why not we take a 10-minute break? We can grab some coffee and then wait for the stack to deploy. Does that sound good? Okay, let's take a 10-minute break. Already opened AWS console from the workshop? Yeah, you need to log into the AWS console. So for the stack to deploy, you need to already be logged into the AWS console in your workshop, where when you open the workshop instructions, on the bottom left, you have the open AWS console option. So let's meet back at 9:50.
I've noticed some folks in the audience that are. What time did you say we'd get started?
Yeah, right in a minute.
Okay. Well, we can wait. I've noticed a couple of people getting stat creation failed.
Oh,
Yeah.
probably selected the wrong subnet.
Maybe.
The subnet is
So I think if you can get them through the service role,
yeah.
that'd be perfect.
Okay. And then you start with 3.
Yeah. That's cool. Unless you want to do more, I don't care.
No, I don't mind, but it's up to you. Where do you think like it goes very detailed? Probably 3.
Starting with 3. Yeah.
So then I can get them.
Okay. Yeah. Let's see. I'm curious how many people are having a problem. You're probably right.
Yeah. Yeah. So we'll start in a minute. Yeah. Hi.
What's in the box?
Yeah, so the IT team is setting up something. While they're doing that, how many of your CloudFormation stacks are successful? Can you see they're successful, or do you see they're failed? How many of you see failed? Okay. So make sure that when you launch the stack, you have the right subnet, which is the last one which ends with 0.0, and make sure you're in the right region.
Anybody else? Stack creation failed.
So we had more than a 10-minute break, but we are good to, like, if everyone's stacks have been deployed, we can start. You'll see that the deployment has been successful. So let me open my stack. You'll probably see in the stack info that create complete as the status. And once we do that, you'll, okay. So you will see some outputs where you will have the VS Code server password and VS Code server URL. So this, in the outputs, the URL, which is like a cloudfront.net URL, this is where you will be able to log in to your VS Code. So open it in a new tab. And when it prompts for a password, copy the password that you see in the output section. So it will be in the outputs, the URL. And you will see a get started screen with VS Code. Now we'll be running our AWS command line interface commands on the VS Code terminal. So in the tab bar, when you are in the VS Code server, it says file, it says terminal, and then click on new terminal. So you'll see a screen with the terminal open, which helps you enter commands. On the next step, we'll be running AWS CLI. So AWS CLI is basically through the terminal, you can access the AWS console, not AWS console, but access AWS and run commands against AWS services. So but for that, we'll need login credentials to securely access AWS. So for that, we'll be creating an IAM user. No, actually we don't, because you are not using your own AWS account. We have already provided, so we have the credentials in the workshop section. So you can retrieve the credentials in the same tab where you were able to log in the workshop link, where you were able to log into the AWS console. You will see get AWS CLI credentials. So if you click on get AWS CLI credentials, select just copy the first one, which gives the access key ID and secret access key. And we'll just paste it. And this will log in. So once you paste it, click on enter. And we'll be storing those credentials. And then once this is done, we will just make sure that all the region, key ID, secret access key, everything is set. So we'll just copy the command after in the 2.2 section of the lab. Copy the command after the credentials section, which is option B using AWS provided account. The command says echo region, echo key ID, etc. So copy that and paste it. And you should see the output there, the right credentials and the region, etc. in your terminal. Let me zoom in the terminal. So once we have that ready, we can log into the, and the next step we'll be doing is the IoT Greengrass server. Is everybody, by the way, has been able to copy the credentials in the terminal?
Who's having problems?
So you should see something like this in the output. So these steps are just so that you can log into the AWS CLI, and then from here we'll be installing the Greengrass component. Anybody else having issues? So once you're all logged in, once you have the credentials, the next thing is Greengrass. Now, IoT Greengrass needs to have permissions to access resources on your behalf. This role is needed for section 6 or the lab 6, which we'll be doing later. But let's just set up this access permissions role for now. So we'll be installing. We'll be following the installation steps. But the first step is install the JQ utility. So copy that step in the same terminal that you have on VS Code. So this just lets you run JSON scripts. And then we'll be running this JSON script where we'll be creating this service role, which says that, and you may also do this with other AWS services when you want to assign a policy or permission for the AWS account to access resources. So we'll copy this service role. And we'll be running 2 commands along with that. Copy the whole command, and we'll be attaching that role to a policy and associating that policy to the IoT Greengrass service. So this is all done through the AWS CLI. And we click on enter. And you'll get a output that says associated, the role is associated. And once to verify if the service role has been created successfully, We'll go back to the AWS console, the tab where you have the AWS console open, and we'll search for AWS IoT. Let's say core. Huh? Yeah. Yeah, has everybody attached the policy successfully? Did they get associated? So just IoT, search for AWS IoT. I think instead of IoT, search for IoT core. And you will see a page for AWS IoT. So search for IoT core, and on the left menu, click settings at the bottom. And when you scroll, you will see at the bottom of the page, the Greengrass service role that you just created is associated through the AWS CLI. So from here on, we'll be working on the AWS IoT console, and it will be assuming this role and policy to perform all the operations that it is doing. So can everybody see this policy associated at the end of in the IoT core console? All good? So the next steps Darren will be walking through, will be diving deep into actually setting up and running the components and testing out the IoT core, IoT Greengrass devices. So I'll hand over to Darren, but feel free to ask me any questions. I'll be walking here. Yeah, sure.
Thank you. Greetings. So what did we just do? So we have an EC2 instance, Visual Studio Code installed on it. We have deployed a Greengrass service role, and I want to kind of talk about like why that's important. So Greengrass, I mentioned earlier in the presentation that Greengrass communicates primarily with IoT Core, but it also can communicate with other AWS services. That's what this Greengrass service role is doing. And so this role that we have set down here at the bottom just provides permissions to access some other services. We're also going to talk about a token exchange role here in a little bit. But basically what we've done is we've set this environment up, and we are now ready to install Greengrass. If you are not at this point, raise your hand and one of us will come around and we'll help you out. All right, so talk a little bit about Greengrass. So we are going to install Greengrass version 2 on top of our Ubuntu Linux instance. And all this means is that we're just going to install the Greengrass client software. It's just that easy. So there's a couple of different ways that you can install Greengrass, and we're going to walk through 2 of them today. The first time we go through this, we're going to take the old school way, and we're going to do this manually, and we're going to run the installer. That way we can all kind of understand what's going on. And then a little bit later in the workshop, we're going to build Greengrass using fleet provisioning by claim, which is super cool because we can automate like millions of devices with it. So what we want to do is we want to go into IoT Core, the console, and we want to set up a new Greengrass device. And so you're going to see me kind of flipping back and forth between screens a little bit. So I'm in IoT Core. I'm going to zoom in a little bit more and see what that looks like. Perfect. Okay, on the left-hand side, an IoT core, and I'm paying special attention to make sure that my region always says US East 1, North Virginia. I'm going to go under the Manage menu. I'm going to find Greengrass Devices, and I'm going to click on Core Devices. I don't have any Greengrass devices right now, and so that's what I want to do, is I want to build one. So I'm going to click on the Setup Core Device dropdown, and I'm going to set up a single core device. So we can call this core device whatever name you want. Keep it clean. I'm going to call mine let me move this over. My Greengrass device. So we also need to provide a thing group name. So a thing group is like, where do we want this Greengrass device to hang out at on the weekends? And we use this thing group to automate the deployment of software to devices. And so I see customers creating thing groups of thousands of devices, and then we use that thing group as a target for deployment, and we're going to walk through that together too. Let me think. I don't believe that we have any. We can leave this as Greengrass Quick Start Group. At the very bottom, remember I talked about two options earlier. So we have Greengrass Nucleus Classic. And just because it says Classic does not mean that we're deprecating it. It's still actively being developed, but what we refer to as Classic is actually Greengrass V2, and that's the one that we want. Nucleus Lite was the one that I mentioned earlier that's for primarily like power-constrained devices. We are going to run this on top of our Ubuntu EC2 instance, so we'll select Linux. And I do believe I want the option set up a device by downloading and running an installer locally on the device. So we're going to get some installer execution commands. So these two at the bottom, I have one for download the installer, and I have one for run the installer. So the first thing, obviously, I want to actually run this installer. Let me see what that looks like too. Is that easy for everyone to see? Cool. All right, good. We can get rid of this little Copilot thing on the right. I don't know what that is, but it's kind of a joke. All right, so I'm going to paste in my curl command. This is downloading my installer zip file for Nucleus, and then it's unzipping it so that I can run it. I'm going to go back to my IoT core screen. Now I'm going to run the installer. So there's a couple of things that's like that I want to point out here. So we do have a JVM dependency on this, right? So we're running that with the installer. You'll see the greengrass.jar in there. We are providing a region, so everything in AWS IoT is always bound to a region. So in our case, we're in US East 1. We have our thing name and our thing group name. So Greengrass devices always create a thing in IoT Core, and I'm going to show this to you after we install it. And so this is just simply my thing name. See my thing group name, which is the Greengrass Quick Start group. The other thing, though, and the most important flags that I've got on here are these at the very end. We always want to specify a default user for any components that are installed on this device. When that component runs as a process on the Greengrass device, it's going to run as this user. So it's super important just to make sure that we're specifying the appropriate user for this to run as and group for this to run as. Provision flag just says, yes, I want you to build a cloud-side device for me. System setup service means, yes, I want you to run Greengrass as a service on Ubuntu. And the dev tools means, do I want to install Greengrass CLI by default? So that's what we want. Probably more than you guys wanted to know. All right, so I'm going to paste this into my terminal. creating my user, creating my group, provisioning my AWS IoT resources. We'll see a new IoT policy, key, certificate, and I'm going to go into all of this stuff so that you kind of understand what's actually being created. This TES role that you'll see here, TES stands for Token Exchange Role. And what a TES role is it's a way for this Greengrass device to authenticate to other AWS services. And so this TES role policy will be the AWS IAM policy that governs which services this device can get to. Perfect. So we've got Nucleus set up as a system service. Everything looks good. If I go... I thought you were going to attack me.
No. Which lab are you in?
I am in 3.1.
Okay.
I had a Will Smith joke, but I'm going to save it. All right. Sorry about that. No, you're good. Okay. So I want to make sure that Greengrass is installed on my device. I forgot. I didn't tell you guys what I'm doing. So I'm copying this command. It's using the Greengrass CLI. Greengrass CLI is just a local tool, local development tool that we've put on this device through that installer command. And there's my Greengrass CLI version. So if you don't see this, if you get a file not found error or anything that doesn't look exactly like what you see on the screen, just wait a minute. Greengrass is probably just getting started and should resolve itself within 15 seconds. If it doesn't, raise your hand and let us know. I'm also going to check the status of my Greengrass service. And that's this sudo systemctl status greengrass.service. And I paste that in. I can see service is running, and it is running as a startup service. It'll run on startup. So we don't have anything to do. Anytime this device reboots, it's automatically going to install or run our Greengrass service. So I'm going to deviate a little bit, and you guys don't need to follow me, but I want to show you what was actually done within AWS IoT. So once we're done, I'm going to click on View Core Devices, and I see my device listed here, my Greengrass device, with runtime of Nucleus Classic. If I click on this device, I'm going to see the Nucleus version 2.15, which we've already verified. My device is healthy because I'm communicating with the AWS cloud. You can see that we've installed it on Linux, and I can see that I have a single component that's running on it. There's actually two components that are running on this device. Nucleus is always required. And we'll see this a little bit later, but where we can list out the components that are running on the device, Nucleus will always run. Nucleus is Greengrass. They're one and the same. The Greengrass CLI is an optional component that we've also installed. It's a dev tool by way of the flag that we called when we ran the installer. This deployment is my initial deployment to this device. And a deployment is just a way for us to deploy software components to Greengrass. We are going to come in and modify this in a minute. We can see our thing group. What else did I want to show you here? The other thing I wanted to show you actually is if I click into this thing group, I'm going to see a thing. Makes sense? This thing is also called my Greengrass device. I'm moving around a little bit on the left-hand side. Why is it called a thing? I don't know. That's a good question. I really don't know. There we go. I'll roll with that. That is literally why. So there's no pun here. The thing I wanted to point out here is all Greengrass core devices are things, but not all things are Greengrass core devices. What do I mean when I say that? If you were to build a thing using the AWS IoT device SDK, you have to have a thing to authenticate to AWS IoT. You can also have Greengrass installed on your thing, or you cannot. That's the statement. All Greengrass devices are things, not all things are Greengrass devices. Makes sense, okay. So let me go into this thing. Because we're at a cybersecurity conference, I feel as though this is an important point to point out. So this thing, how does this thing authenticate? It uses an X509 certificate, and it performs mutual TLS authentication, which I know everybody in here knows what MTLS is. Also with the certificate though, so that's great, you can prove your authentication, but what are you authorized to do? All certificates in AWS IoT, and remember, anything that talks to AWS IoT is a thing, they all have policies associated to them. This policy determines what in AWS IoT this device can do. And so we'll see IoT Connect, publish, subscribe. These are all things that we do within the MQTT ecosystem. Makes sense. All right, so we talked about the thing, the certificate associated to the thing, policy associated to the certificate. I think we're good. Let me go back to our lab guide. Let's move on. All right. So now we need a core device role. So I'm going to pop open the AWS IAM console, and I like to favorite these things and open things in new tabs. That's a fun fact about working for AWS, is that you end your day with like 100 tabs open. So what I'm going to do actually is I'm going to first create an IAM policy. I'm going to scroll down a little bit, and we see some JSON here. Let me make sure I'm not skipping any of this. I see S3, Greengrass, looks good. All right. I'm going to copy this policy out. And I'm going to go into IAM, create policy. I'm clicking on JSON. I'm going to delete that entire policy, and I'm going to paste the one in that I just copied from the lab guide. So this is creating a bucket, listing bucket, get bucket location for all buckets. I see all actions on AWS IoT. Again, this is a workshop environment. I would not recommend doing this in prod. And all Greengrass actions, same feedback. All right, so that's my policy. And I am going to give it this name. It's a little hard to see. Workshop S3 IoT Greengrass policy. So if you get any errors on the left-hand side, that just means your policy syntax is incorrect. I'm going to paste in that policy name. Don't need to give it a description, and we're good to go. Okay, so now what I'm going to do is I'm going to go on the hunt for a token exchange role. So I'm going to go to roles in IAM, and I'm going to find the one that says Greengrass V2 token exchange role. So I just spent all of this time talking about things and certificates and policies. And you were probably wondering to yourself, well, all of these statements within that policy said IoT. That's where the Greengrass token exchange role comes in. So I've got this Greengrass device. To using a certificate to authenticate to AWS. When that authentication happens, it will use the policy associated to that certificate to determine what within the AWS IoT ecosystem that device can do. If you want to talk to something outside of AWS IoT from your Greengrass device, that is where this token exchange role comes in. And so what we are going to do, so we configured a token exchange role when the installer ran. And now what we're going to do is we're going to take that new policy that we created and we're going to attach it to this role. So now I should have two policies. This Greengrass V2 token exchange role access, really all it does is allow this device to upload logs to CloudWatch because logs are cool. This other one that we created allows this device to create buckets and do pretty much anything within AWS IoT. Again, this is a workshop environment. All right, so that's what we did. Everybody on track? Anybody have problems? Well, I know you do, Kai.
Yeah. So when you run that 3.1 installer, after that, if we get an error, no such file or directory, what could be the reason there?
So the likely culprit is that we just didn't give it enough time.
Okay.
So if you run that greengrass v2 bin greengrass CLI-v, just give it another shot. See if it works.
This will be try 3, so third time's charm.
Oh, this is try 3.
Oh no, run the curl and sudo command.
All right, everybody else good. I appreciate you not booing me. All right, so we're going to create our first component. So I'm going to scroll down to our little diagram here, and we'll talk about what we're creating. So our first component is going to be really simple. It's just going to be a little Python script that says hello world. In this component, if I go back to my greengrass device, it's going to be installed on it. And we're going to get this component to the greengrass device by way of a deployment. Okay. So the first thing we need to do is we need to create the component, just a little software artifact. So I'm going to copy this command. What are we doing here? We are creating a new directory under artifacts. Actually, let me back up a little bit. All components in greengrass are comprised of recipes and artifacts. An artifact is the software code that you want to run. In this case, we are creating hello world.py. A recipe is a JSON or YAML instruction to greengrass that says, what do I do with this artifact? How do I install it? What dependencies does it have? Very simple. So we're starting by creating this component artifact. And this command is just creating a new artifacts directory, and we're creating a hello world artifact. We also version all of our code because we're developers here, right? That makes sense. And we also tend to use, and I don't know the answer to this, we also tend to use the standard naming convention. So hello world.example.com in my case. Okay, so I'm going to copy that out. And it really bothers me that this isn't in dark mode. Let me see what this looks like. Oh, I think that's better. Yeah, all right, we'll do that. They use white background? Real developers? Senior developers. You wait until your retina's burn out. All right. Let me clear this real quick. All right, so I'm pasting my command in here. Make directory, touch a file, hello world.py. Boom, I can see it. It's right there. And I'm going to open that up in VS Code. And now I just want to copy this code. Let's take a look and see what it does. All right, so we got a couple of import statements, creating a message with a date time. And then we're writing this to greengrass hello world.log under the temp directory. And then we're sleeping. I'm going to Control S to save that. And that is our artifact, pretty straightforward. Now I need to create my recipe. And I'm sorry, I got to do it here too. now I'm going to create my recipe. So I'm going to copy this command, and I'm going to enter that in. And then I will also see I have an artifacts directory, and I have a recipes directory. So I'm going to open up that recipe, and I'm going to copy this recipe definition, and we'll talk through this. So my format version, just like CloudFormation, every recipe has to have a version. We're giving this our component name. This is what we're going to see when we look at the component and when we discover it. Component version. Component version in this case, it is needed, right? Because if I updated this component, obviously I'd want to update the version. But where it's also really important is where you have dependencies between components. So you may have a couple of different software packages running on your device, and you want to make sure. Let me put it a different way. You could say that anytime somebody installs Hello World, I'm also going to require them to install something else, and Greengrass will do that for you automatically. So component version, super important. The default configuration, so we're providing a default configuration of world. And what's going to happen here is that we are going to read this in to our Python file, and we're going to populate it right there. Okay. Sorry, I get off track when I start talking about stuff. Where was I? Oh, I was in our recipe. Manifest, we can specify a platform, so if you wanted to restrict this component to specific platforms, you can. Lifecycle, gotta have it. It's very important. It says, when you deploy this component to Greengrass, what do we want to do? And in this case, we are running our hello world.py, and we're populating in our configuration into that. All right. I'm going to save that, and I'm going to go back to my lab guide. So that's it. Created a recipe, created an artifact, and we'll move on. All right, so what we want to do is we want to launch a new terminal, and we want to tail the Greengrass log file. The reason that we want to do this is because, and I'm going to put a dash big F on there so that it'll keep it running. So as we install things to Greengrass, it will show up in this log file. And so we've run this as sudo, so just remember your log file is sudo over here on the right, your regular terminal is just bash. Cool. All right, so now I'm going to copy this command. So I mentioned to you earlier that we use deployments to get things onto Greengrass, and that was true. The part that was not true was that we don't necessarily need the cloud to do it. So what I am doing here is I'm using the Greengrass CLI, and we're going to explore this both ways. We're going to do it locally on the device, and then we're going to do it from the cloud. So Greengrass CLI, this command specifically, is just a way for us to test this component. So before I go through all of the effort of uploading this component to, and it's not a lot of effort, but before I go through the effort of uploading this component to the cloud and creating a deployment revision, let's just test it locally just to make sure that it actually works. So that's what this command is doing. And to run this, I'm going to open, sure, I'm going to open up another new terminal. All right, so sudo greengrass v2, I'm calling Greengrass CLI, my local development tools. I'm telling it to create a deployment. I am providing the recipe and artifact directories, and I am telling it a merge statement. And I'm going to hit enter. Created my deployment. If I look at my log file, you'll see that deployment get created in here as well. And if it works, it should say finish successfully. Cool. So we got the local deployment submitted. And And now what we're going to do is I realize that I have 3 terminal windows open here. In my first one, I'm going to tail. Remember that my little software program is writing to temp, greengrass hello world. Well, let's see if it's working. There it is. So every second I get a new timestamp. So I know that my code works. I haven't created a deployment in the cloud. I've created it locally on this device to test, but it looks like it works. So I'm going to Control C out of that. I'm going to flip back to my lab guide and confirm that we are seeing what we want to see. Cool. Okay. All right, so now what we want to do is, now that I've built this component locally, I want to deploy it to the cloud so that I can share it with others. And so that's what we're going to do in section 4.3. All right, so before we can deploy it to the cloud, we need to store it somewhere. And we are going to create an S3 bucket to do that. So this part is super important. So I'm going to copy this command. This is just creating an epoch time, and it's populating that. It's just creating a unique S3 bucket name, right? Because globally, S3 bucket names have to be unique. So we're creating that. Another Will Smith moment. Are we going too fast, too slow? You want me to slow it down? You want me to go faster? Oh, I am going a little fast.
Yeah. So in which lab everyone is at right now?
We're at, did someone say 3.2? Did you say 3.2?
Well,
Okay.
How
It
about
is very important to us that everybody comes along for the ride. So
who is the fastest right now? Is everybody at 4.2? Okay, so maybe
do we want to take a little break? We've been going for an hour. I'm cool with that. Do we want to take 5?
yeah, sure, let's take 5 minutes.
I feel like we're getting some mixed reactions from the audience here. Okay. Let's take 5. We're going to catch up some people, and then we'll come back and we'll start with 4.3.
Okay. This time I came in slow.
Okay. Yeah, you did go slow.
And then Archie. Better. The large table in the back corner.
Yeah, okay.
What time are we breaking for lunch? 12? I'm gonna slow way down. I get excited when I talk about IoT because it's super cool, and I challenge everyone to go home and take a $20, I don't know, Intel Nook or something and put green grass on it. You'd be surprised with what you can do. Okay. So I'm gonna, yes, Kai. 12. Okay, thank you. What'd you say, Kai? Oh, that's good. Yeah. Let me go back. Since we're going slow. So you're talking about when we have cleanup previous, this one, cleanup link to earlier deployment? And no timestamps. I think what's happening is I think the original deployment may have failed, and that's what you're seeing. Did you tail the hello world log? This guy right here. No such file or directory. All right, let's just back it up a little bit. Let me talk about what we did. So I'm going to start at 4.1, and I'm not going to walk through every command, but I'm just going to talk about what we did. So this first command here, remember I talked about how every component, every little piece of software has to have an artifact, which is the code, and a recipe that defines what to do with the code. So what we're doing here in this first command is we're simply creating a directory to store our artifact, and we're touching a file called helloworld.py. We're creating an empty piece of software code. In VS Code, after I run this, I will see it right here. That's my hello world. Now mine's populated with actual code because in step 2, we copied this code out and I pasted it in this file. So that's our artifact. And then we did a pretty similar thing for creating the recipe. I made a new directory called recipes under Greengrass core, and I touched an empty recipe definition. And we see that in VS Code right here. And then the last step of this process was take our recipe definition, this box, and paste it in here. And all this does is describe again, when we deploy this component, what do we want it to do? That's the recipe. How do we want to make the cookies? Or brownies, or cupcakes, whatever your flavor is. Okay. So now we've got an artifact, my code, a recipe. What do I want to make with this code? And that brought us to section 4.2. And in 4.2, what we did was we opened up a new terminal window. This one right here. And I tailed my Greengrass log. Everything Greengrass, when you install it on a Linux or a Windows box, it's always going to install in the Greengrass v2 directory. And under that, you'll find various directories for logs, components. And so here I'm just tailing my Greengrass log. And a little fun fact, every component gets its own log too. And we'll get into that a little bit later. Okay. So I just tailed the log just so that I can see what happens when I do stuff within Greengrass. Number 3 here says I want to now create a local deployment. The only way to get a component onto a Greengrass device is to create a deployment. And you have 2 options. You can create a local deployment or you can create a cloud deployment. We usually recommend start with a local deployment to make sure that your code actually works. And that's what we've done here, is we're using our dev tool, greengrass-CLI, to create a local deployment. We're passing in our recipe folder and our artifact folder, and we're providing a merge statement. And then we get confirmation that the local deployment was successful. And that's when I'm now able to tail. So this particular component is writing logs to temp directory, and that's what we're doing. I'm tailing my temp directory to make sure that this component's actually running. And it'll just continue to run because that's what software does, right? So at this point, I know that my recipe's good, my artifact's good, and I know that because I've created a local deployment and I'm running it on Greengrass, and I see it continue to run. Yes, Will
So
Smith.
if the some people see like sudo errors, like password errors, what could be the reason for that?
So my assumption is that at the start of the lab, we opened up a single terminal window in VS Code. This one here at the top, where I'm currently tailing this file, that is the terminal window that has your AWS credentials defined within it. The sudo error, I'm not sure. Where are they getting the sudo error?
When they try to create the deployment after the logging.
After they log in.
Yeah.
So when you run this command,
Yeah.
you get an error.
Yeah.
You don't get local deployment.
No, just sudo password.
How many people are running into this error? 1. I'm sorry, I didn't mean to out you. I would probably verify that the Greengrass CLI is in that directory. Greengrass/v2/bin, and then ls in that directory, and you should see Greengrass CLI. Matter of fact, if you do lsal, you should see the permissions, and you need to be able to execute that file. Am I talking too much? I'm sorry. Okay. It's not there. That's why it doesn't work. So how do we fix it? So we fix it. If I look at my Greengrass core device, it's registered to the cloud. I can see that it's healthy. In my case, I now have 2 components running, Hello World and Greengrass CLI, even though I did not deploy this component from the cloud. Remember, I deployed it locally. It'll still report back to the cloud. So how do you get Greengrass CLI on a device that doesn't have it installed. Well, we installed it with the installer. What you could do, however, is you could go into your deployment, because every device has a deployment, and you could click on your deployment, and you could revise that deployment. And you could select, I'm not going to go through this process, but you could select Greengrass CLI from your public component, and that'll put it on the device. Cool. Awesome. And we are going to get into deployments if we have enough time. Okay. Actually, we're going to get into deployments right now because it's super cool. Okay, so hello world, working locally, and it's even reporting back to the cloud as it's installed on my device. So now I'm going to move into 4.3. And step number 1, this first command, I'm going to copy this, and I'm going to go back into, and this is super important, I'm going to go back into the original bash terminal where I exported my AWS credentials. Because if we don't go into that terminal, this command's going to fail. Good news is, you'll know immediately. So I'm going to paste that command in. All it is doing is it's creating a variable for an S3 bucket name, and it's feeding in epoch time, and then it's using AWS S3 make bucket, and then it's passing that in. That's it. So I'm going to hit enter. And it said it made a bucket. And it used my local IP, and it used timestamp to create the bucket. So that's going to be my bucket name. I'm actually going to copy that. You don't have to follow me, but I'm going to go into the S3 console. I'm going to favorite that because I like doing that. I'm going to open that up in a new tab. And I want to make sure that my bucket's actually there. And there it is, right there. So that's all we did with that command. We created a bucket. Now what I'm going to do is I want to update my recipe definition to this code. And this is going to be a little tricky. So I'm going to copy this code, and then I'm going to show you what we need to do. So I copied that code out, and I am back in my original recipe definition for the component that I've deployed locally. Now what we're going to do is we're going to deploy it from the cloud, okay? And so I'm going to Control A, and I'm going to nuke out that entire recipe definition, and I'm going to paste in the new one. Here's the important part, though. You'll notice that most of this is exactly the same. Same component name, same component version, same message, hello world, default configuration. What's different, though, is the life cycle. Actually, no, the life cycle is exactly the same. What's different, though, is the artifacts path. So remember, the recipe says, where do I find the artifact? The artifact being the code itself. And so here we have a URI. We're saying, when this Greengrass device gets this recipe, where do I find the code? And so we need to put our new bucket name into this recipe definition. That's it. So I am going to copy my new bucket name right here. Just going to copy that out. And I'm going to replace the open and close bracket and the S3 bucket name. So yours should look S3 : / your bucket name / artifacts, blah, blah, blah. Keep going. And then remember, we want to save that. So Control S in VS Code. Cool. And if you need your S3 bucket name again, just run an echo S3 bucket. I'll do that too. Perfect. And you can copy it that way. All right, so now what we're going to do, we're going to upload our component artifacts. So I'm copying this command, AWS S3 copy, recursively, anything in the home Ubuntu environment greengrass core directory, and I'm going to copy it to the new S3 bucket that I just created. We are actually going to copy, I don't like, it says component artifacts here. Technically what we're doing is we're copying both my artifacts and my recipes, right? So I'm going to paste that command in. Perfect. So it ran, and I'm running this command from the bash terminal where I've specified my AWS credentials. And now if I look into my S3 bucket, I should see a recipes and an artifacts directory. Artifacts with my code, recipe with my recipe. Okay. So that was viewing our upload. Now we're going to create the component definition in IoT Greengrass components. I'm going to go on a quick little jaunt through the forest and talk about what this means for a second. You don't have to follow along with me. So under Greengrass devices and IoT Core, on the left-hand side, we're going to see a screen that says components. And remember I talked about earlier, we have three kinds of components. Personal components that you write, public components that we provide, AWS, and community components that others provide, and we've provided documentation on these in GitHub. And you'll see there's a whole bunch of them, and they're wonderful. So what we need to do is we've uploaded our recipe and our artifact definition to S3, but we haven't yet actually created a component, and that's what we're going to do. So we're going to create a little Hello World component, and we'll see that listed under My Components. So this command here, I'm going to copy it, and I'm looking at this error. We should not have a problem with this, but if you do, raise your hand. So I'm going to copy this command, I'm going to paste it in my terminal, and then I'm going to talk about what it does. And I'm going to clear this just to make it a little easier to read. All right, so I am changing my directory to home Ubuntu environment Greengrass core recipes. So I'm navigating in to the directory that contains the recipe for my Hello World component. I don't know if that's me doing that, sorry. I am then going to use the AWS CLI, specifically AWS Greengrass v2, to create a new component version. And I'm going to include an inline recipe file, and I'm going to specify an AWS default region. So what this command is going to do is it's going to take this recipe definition and it's going to create a component for me in the cloud. So I'm going to hit enter. And you should see a message that looks very similar to this, where it says requested is my status. I don't know why I'm getting that. But now I'm going to go back into AWS IoT, and I see my little component with my version of 1.0.0 because it got that version from the recipe file. So all we did was we took that little component that we tested locally, we just put it in the cloud. That's it. And that is what enables us to deploy it to thousands of devices. Cool. Okay, so we all got output that looked very similar to this. So that is good. If you had any problems, if you don't see, actually let's just pause there. Let's go back. If you don't see your component listed in the cloud, I don't want to out people, but throw something at one of us and we'll come over and help. But we should all see it listed. We can also use, and you don't have to do this, but I will just to show you. We can also use the AWS CLI. It's really hard to type when you're I'm really not sure what's going on with my VS Code terminal window. Let me refresh that page. That is weird. Works there. All right, so this terminal is locked up for me, so I'm gonna kill it. I'm also gonna kill that third terminal, but I'm gonna leave the one that's tailing my log. And I'm gonna take a quick little jaunt, and I'm gonna go back. I'm gonna get my credentials, and I am going to open up a new terminal. We will try this again. That looks good. And I'm gonna paste that in. All right, perfect. All right, back to our originally scheduled programming. So I am now going to use the AWS CLI. So AWS Greengrass v2 list components in my region. And you'll see my component listed. It's the exact same thing that we see on this screen right here. Awesome. All right, so now we're ready to deploy the component. This is like the best part about Greengrass, in my opinion, is the ability to do this. Think like you're a device manufacturer with 20 million thermostats out there, and you want to deploy some new functionality, or you want to change everybody's temperature to like 90 degrees in the summertime. This is how you do it. Okay, so first we need to clean up our previous local installation. Remember, we tested that component locally. It's still running, and we want to get rid of it. I'm going to take a quick little aside real quick, and I'm going to show you a command that you can use. So remember, in the console, if I go to a core device, I can see the components that are running on it. How do I do that locally? I would go to the device. I would call Greengrass CLI. This is what I get for going off script. I was right the first time. I just had an extra S in there. Okay, so I called the Greengrass CLI, and I specifically called component singular list. And this shows me everything that's running on the device. And I can see my little hello world component. I can also see the configuration that I passed into it. And what I want to do is I want to get rid of it because I want to deploy it from the cloud. That's what this command does. So anytime we change something in Greengrass software, we always do it with the deployment. We always create a new deployment. This time, we're creating a deployment that's telling this device to remove a piece of software that it has installed. So I'm going to run this Greengrass CLI deployment, create, remove, and I'm going to pass in my component name. Makes total sense, right? Perfect. Again, I get local deployment submitted. And I'm going to up arrow a couple of times, and I'm going to go back to Greengrass component list, and I'm going to see. And sure enough, it's gone, which is good. That's what we want. I can also go back into IoT Core, and if I refresh this page, I should see hello world gone from here as well. Just looking at it, it's the same data, just looking at it two different ways. All right, so now we're ready to deploy it from the cloud. And this is how people do this at scale. And so remember, I mentioned earlier that every Greengrass device has a deployment, because that's what we used when we installed Greengrass. That's what put Nucleus on this device. So I'm going to go into my core device. So I went in, let me back all the way up if you're not here. I went into the search bar. I typed in IoT. I'm going to favorite IoT Core, click on the IoT Core console. On the left-hand side, I'm going to go down to Greengrass devices, Core devices, and I'm going to find my Greengrass device. And then I'm going to go to deployments, and everybody should have one deployment listed, and I'm going to click on it. And this deployment, and again, this is a super cool thing about deployments in Greengrass in general, is that you'll notice that this has a revision on it. I've only created one cloud deployment as of right now when I put Greengrass on this device. So I only have one revision. So what I want to do is I want to click on Actions and I want to revise. So this looks like an error message, but it's really not. What it's saying to us is it's saying, hey, just so you know, this deployment has devices that are targeted. If you change this deployment, we are going to make the devices look just like whatever you have on this deployment. That's what I want. So we don't have to specify a target. And if you were to create a deployment from scratch, you can target a deployment to a single device, or you can target it to a thing group. Remember, we created that thing group earlier. In this case, I'm targeting it to my thing group. I can't change it because I'm revising a deployment, and that's totally fine. So I'm going to click on Next, and here's where we select components. So now I can see my component listed. So I'm going to select it, my Hello World component, and I'm going to click on Next. That's all that I'm doing here, selecting my component. And now what we're going to do is we're going to configure this component. So you remember earlier, let me go, where am I going? I'm going to go back into my recipe definition. Remember I had a default configuration for this that said world. And originally, it would output to my component log, hello world, from whatever timestamp. Well, what I'm going to do now is I'm going to go in and I'm going to change this configuration when I revise this deployment from the cloud. And so I want to copy under 4.4, number 5, I'm going to copy message this was deployed from IoT Core. And when I'm revising my deployment, we should all be on the Configure Components page. I'm going to select the radial button next to Hello World, and I'm going to click on Configure Component. Also, one of the super cool things about components in Greengrass is that I can change whatever is in the recipe tells me what to do with the artifact. And it may optionally include a default configuration. I may choose to change that configuration when I update these components from the cloud, and that's exactly what we're doing here. So in this configuration to merge box, I'm going to get rid of that empty JSON. I'm going to paste in my new JSON that I copied from the lab guide. And now I'm going to confirm it. I don't need, so you see also that I have my version here, and that I have modified the default configuration for this. That's exactly what I want. And now I'm going to click on Next. I'm not going to spend a ton of time, but imagine that you had 10 million devices. You may want to stagger the deployment schedule. You may want to build in some retry logic. Invariably, something's going to fail if you try it 10 million times. That's really what this advanced settings screen allows you to do. And then I'm going to go to the review screen. I'm going to scroll all the way down, and I'm going to click on Deploy. So now this is all queued up for me. And what I will see in the middle of my deployment screen is the execution should immediately go to queued. If I keep refreshing this impatiently, it'll go to 1 in progress. And then eventually, I should see succeeded turn to 1. And I'm just going to continue to click. What's happening right now? Yeah, that's what I should talk about. What's happening right now is this device, and you don't have to follow along with me, but I want to show you the logs because it'll help you understand. This device has received a new job definition from the cloud. And it's saying, what do you want me to do? And so this device is reaching out to S3. It's downloading that recipe and artifact definition, and it's starting it. And so if I go back to my deployment, now it's successful. And if I look at my core device, I will see my Hello World application running. And also, if I go back to my device and I up arrow to list out my components, I should also see my Hello World application running. But the cool thing here too is that I've got my new configuration. And this was supplied when I revised that deployment. Okay, so we have verified the deployment. Everybody should have succeeded equals 1. And that one value, what does that mean? That just means that you have one device as a target in this deployment. We have tailed our Greengrass log, our management logs. That's what this was. Deployment status succeeded. Thing group deployment, current state running. If you want to read through all of these, you can. Now we're ready to check our component log. So I didn't change the artifact definition. It's still writing to temp. So now if I go into this, tail that log, now I get, hello, this was deployed from AWS IoT Core. So it's picked up that new configuration from our deployment in the cloud, and it's still running. I already ran this Greengrass CLI component list, but I will run it again. That just tells me what is running on this device, and it should mirror what the cloud says. And that's it. So the last thing that we'll get into on components is we will talk about versioning of these components. Everybody cool up until this point? All right, sweet. All right, so we're going to talk about versioning of deployments. So I'm going to create a new component version. And in this case, remember, we have a single EC2 instance that's running VS Code. It's also acting as our IoT device. In reality, you're going to have a development environment, and then you're going to maybe put that on a single device and test it. We're doing it all on one device here. And what we're going to do, so I'm in 4.5. I am going to copy out this command, and we'll talk through what it does. Let me clear my screen. I'm going to paste that command in. So all we're doing is creating a 1.1.0 directory for a new component definition. And we're adding a new artifact called second iteration.py. And let me close out these two files so this makes more sense. Cool. So now I see second iteration.py. I've opened it, and I can see that it's empty. And I'm getting meeting reminders that I'm very happy to ignore. Awesome. So now I want to paste in this new piece of code into our new artifact. Let's see what it says. So it's the same code. We're just changing the logging directory. So now we're not writing to hello world.log, we're writing to temp greengrass second iteration.log. And then we're also changing the actual message. So we're saying hello sysargv, which is the configuration we're passing in from our deployment. And then we say this is the second iteration, and we use datetime to compute that. So I'm going to save that. And I'm going to scroll down to step 3. So now we are going to create a new recipe file. And this recipe file is also version 1.1.0. It should match your artifact definition. Okay. All right, so I'm going to copy this out. And this is a little confusing because we don't actually have a command to create this. So here's what I'm going to do. In VS Code, I'm going to right click on my original recipe. I'm going to copy it. I'm then going to right click on the recipes directory and I'm going to paste it. So I have the original recipe and I have my new copy. So what I want to do is I want to change the name of this. And I want to call this 1.1.0.json.
Hey, Darren.
Yes, sir.
What if someone encounters it's not an error if they run the logs like hello world.log, it doesn't return any output, the hello world output. So what could be the issue there?
Component is not running.
Okay.
So it should be in temp. Hello world.log should be in temp. And if it's not returning anything, let me see if I can up arrow. If it's not returning anything, that means that the component's not running.
Okay. But the deployment was created and it says local deployment submitted.
So local deployment submitted would be...
The previous lab.
Do you see it? Do you see your component running on your Greengrass device, your core device?
Greengrass device. Can we pause for 5 minutes? The internet is down, so we are waiting for the Zoom online part.
Sure, we can pause, yeah. I don't know how many people are running into this, but if your deployment has failed in IoT Core, anybody? Bueller? Failed? One? Okay. So if you click on the error message that says failed in the AWS IoT Core console, looking at your deployment, it'll say failed next to it. What does that mean? There's really only two reasons that this hello world deployment would fail at this point in time. Reason number one is that the Greengrass device was unable to locate the artifact, the hello world PY, in the S3 path provided. So remember, your recipe definition has the S3 URI that points to that specific location in S3. The other, more likely reason this doesn't work is because you remember earlier we created an IAM policy. And that IAM policy we attached to a role called the Greengrass Token Exchange role. Well, when your Greengrass device receives a deployment, and that deployment has a recipe, and the recipe says, go to S3 and download this code. If that token exchange role doesn't have permission to get object from S3, it will fail. So my guess is that if we go into the IAM console, I don't mean to put you on blast, but I'm hoping this helps others. We go into the IAM console, and let's gosh, I wish I could share your screen. Try that deployment again. And oh, so what do I need to do to try a deployment again? Super easy. So if you go back, I'm going to let you do it. Go back into IoT Core. You're in your deployment that's failed, and you want to retry that deployment. In the upper right-hand corner where it says Actions, click on that drop-down, click Revise, and it'll create a new revision of the deployment, and simply step all the way through to the end and click Submit. You don't have to change anything. Just create a new revision of it. Perfect. Revise deployment, and then just mash that Next button. And it'll take you all the way to the end. Yep, keep going. You're doing great. Keep going. Nope, you're good, because it's already been modified. Nope, you can just click Next. Next one more time, and then Submit, all the way down at the bottom. Hi. Most certainly, yeah. All right. I think yours is going to be successful. Yours may fail. I will come back. Where's Kai? I see you. I'm going to come for you. All right. Stop share. Keep sharing. But mute. All right, perfect. Okay. All right, I'm going to finish up 4.5, and we're going to update this component. And then I think we're getting kind of close to lunch. I think lunch is going to be at noon. So I may talk about a couple other things. No, there's no pressure. Like, don't feel as though you have to get through this entire workshop. This workshop will run for the next 48 hours. So if you're a miserable human being like myself and you want to finish this at 2 o'clock this morning, be my guest. All right, let's carry on. So what did I do? I created a new recipe file. I'm going to go back into my VS Code screen. Gosh, I wish I could get that. And I've got Hello World 110 right alongside my original Hello World 100. So what I'm going to do is I've copied my new recipe definition, and I'm going to paste it in. It looks almost the exact same as my original recipe definition. What has changed? Well, my component version for starters is now 110. Makes sense. Also, my life cycle is different because this is not called Hello World. This is called second iteration. So I'm now calling second iteration.py. And what I'll need to do is I'll need to put my bucket name back in, just like I did originally. I'm going to cheat and I'm going to copy it from my original recipe file. However, you could also copy it directly from the S3 console, or you could echo your S3 bucket environment variable. Both of those should work for you just fine. Cool. So I'm going to paste in my bucket name, and I'm going to save. So now I've got my new 110 recipe definition and my new second iteration Python file. So again, what I'm going to do is I'm going to upload these new artifacts. Technically, this command is going to overwrite everything that's in S3, which is fine. So I'm going to copy that command out. I'm going to clear my screen just so it's a little easier to read. I'm going to take everything in the Greengrass core directory. Oh, I bet I don't have S3 bucket set. That's going to fail. S3 bucket. Export. S3. Export S3 bucket equals. Sorry guys, bear with me. I'll be back with you momentarily. All right, perfect. Now I am going to paste this command in, and we will upload these artifacts. Perfect. So now we have all 4 of them. My 2 Hello World recipes, my 2 Hello World artifacts, everything should be in S3. And if I pick on this, I should see, perfect, second iteration.py. So now again, I need to publish this new component version. So remember, my component right now is 100. We've left the name the exact same. It's still going to be called com.example.helloworld, but I want to publish the new version of this component. And so again, I'm going to call on the Greengrass CLI to create a component version. I'm providing an inline recipe file, my 110 recipe, and I'm going to deploy it. And so now what we'll see is 110 listed. So what happened to 100? Nothing. It's still there. As a matter of fact, when we go into the deployment, which we're going to do next, you could still have 100 targeted for a fleet of devices and 110 targeted for some other subset of your devices. And that's, what makes versioning so cool. Okay. So now we want to update to the new version. So our device is running, let me back up. Our device, my Greengrass device, is running 100, and 110 is the newest one. And so what we want to do is we want to go back into our deployment, and I'm going to create, so I am on Rev 2 right now, and I'm going to create revision 3. I don't need to specify any targets. I can't change it anyway because it's an existing deployment. I don't want to change the components that I've selected, so I'm going to go past those. But I do want to select my Hello World component, and I want to configure it. And previously, we had put a configuration to merge here. Now what I want to do is I want to change that version. This is how we instrument the version changes to our devices. I can't remember if the lab guide has us leave the original configuration to merge. So we're fine on that. So all we need to do here is change our component version from 100 to 110. And we'll click on confirm. So then I'm going to click next. Again, I don't need to configure any advanced settings, so I'll click next one more time and then deploy. So I mentioned on the mic, while I'm waiting for this to deploy, I want to show you 2 reasons why this can fail. 2 common reasons why this can fail. The first is that in your recipe definition, this artifacts path, if this is wrong, if for whatever reason second iteration.py is not in this specific S3 prefix, it'll fail your deployment. The other reason why this will fail is remember that Greengrass token exchange role that was actually created earlier for us when we created our Greengrass device. Originally, this token exchange role had only this policy defined on it. And this policy, if you remember earlier, I had mentioned that we have IoT core policies that govern what these devices can do within IoT core, and then we have the Greengrass token exchange role that defines what devices can do outside of IoT core. And this original policy only allowed CloudWatch logs, us to create CloudWatch logs. And so what we did was we went in and we created a new customer managed policy, and we put a bunch of permissions in it, such as get object, which is what is allowing us to download this artifact, and we attached it to this role. If we missed that attach step, that job will fail as well. Okay. All right, so my deployment has succeeded. I see my device listed here, so that's good. If I go into my core device now, I should see this as 110, which is exactly what we want. So now what I'm going to do is I'm going to tail both the original log file as well as the new log file. Oops, sorry, I messed that up. So notice that the original log file is no longer writing logs because we have decommissioned 100 on this device in favor of 110. So if I tail my second iteration, this one should be running with a slightly different message, and it's still streaming output to the log. So we know that it's running. And that's exactly how versioning works within Greengrass. Does anybody have problems getting to the end of that? You had a problem? Okay, I will come by. Okay. I think we've got about 8 minutes left, and I don't want to keep you from lunch. What I do want to tell you, if you're at all interested in continuing along with this lab, there's a lot of things that you can do in this lab. What I would highly recommend is this fleet provisioning. This is like the super secret sauce on how customers deploy thousands of these devices at scale. And what this is going to walk you through is a specific process called fleet provisioning by claim. 30-second elevator pitch. Imagine that most customers are not in the business of building IoT devices. Think about that example with an Alexa device. So you order an Alexa, it shows up at your house, you plug it in, and magically it's ready to go. Well, what happens in the manufacturing process is we will put a certificate on that device along with connection details to get to AWS. As soon as that customer connects that device, they take that default, what we'll call a manufacturer installed certificate, and they will use it to authenticate, they will use it to pre-provision the device, and they will use it to download their own unique device certificate. That is the provisioning claim or fleet provisioning by claim process. Super interesting to walk through. If you want to do one remaining thing within the lab, that would be the thing I would recommend. That's all that I've got. I do want to help those who are still stuck. So I'm going to wander around for a little bit. Thank you for your patience. Thank you for showing up. This has been a lot of fun, and we look forward to our workshop this afternoon. Good. Oh, yes, we have a survey. Thank you. We do have a survey. Our survey, you should be able to scan this from your phone, by the way. You will not have to authenticate. It's literally like 3 questions. Take you 20 seconds to do. We would be super interested in your feedback. I will leave it up for a moment. And thank you. Thank you again.
After the 2 workshops, so stay on until the evening. So now it's lunchtime. Go ahead and grab your lunch, and we have a speaker at Microsoft at 12:30 who will be delivering at virtually. So we'll listen to that at 12:30. So for now, let's eat some lunch right now. Thank you.
AI ML, I was actually an IoT solutions architect, and I was repurposed to the machine learning space. And frankly, I found the IoT more challenging than AI. And I also mean the predictive machine learning too. It's just IoT, it just becomes challenging. I think that's because you're working with the edge and hardware and operating systems. And I guess you could say that you're doing the same thing in machine learning as well. But anyways, long story short, welcome to the afternoon. And this is going to be a lot of predictive AI. The use case would be more around security. And I think there's a real good story and example bridging the gap between the IoT, and especially IoT at the edge, and machine learning, right? And let me ask you, who here is doing AI projects today? Anybody? Okay. And are they more predictive workloads, or is it all Gen AI, chatbot-y kind of stuff? The latter? Okay, so no real predictive AI, no anomaly detection. A little bit, okay. And that's fine. So the workshop that I prepared today is more around predictive, but when we look at that and the concepts that I'm putting out there, it applies across both. So if you're doing more AI engineering versus ML ops and model development, I think it's really good to actually see that process and what it looks like, right? Because that's how your large language models are developed. And there is there is a substantial difference, between AI engineering and building those apps. But our last lab will actually be doing a little fine tuning, and we'll actually deploy a Llama model using SageMaker Jumpstart. And we can maybe cut to that. We'll see how time goes. But I think actually seeing some of the predictive use cases is fascinating. Because again, think about the edge use cases, green grass that Darren was talking about. If we train a model in the cloud, then we can push that down to our security appliances or those things at the edge for computer vision, right? Anomaly detection, all those things. So to me, generative AI is 80% of the hype today, but it's more than, but actually what's deployed and actually being used out there in the field on a day-to-day perspective from law enforcement, power and energy and all that stuff, that is actually predictive AI. So anyways, enough of that. So gonna try to stick to this. And I actually have another, we'll get out of full screen. I've got another more complete agenda as well, just to try to keep myself honest on time. I can get up here talking about the AI services at AWS, but we'll introduce ourselves to the AI platform, primarily SageMaker, which again is for actually building models, but we can also talk a bit about Bedrock, which is more the AI engineering, API access to generative AI tools and whatnot. And then we get a coffee break, and then we'll look at some more complex concepts around model training and whatnot. But again, as we go through this, keep in mind, from the predictive perspective, a lot of that will translate to the generative AI. So the slide that you see up there, this is what I spend a lot of my time on, showing to customers as an AI specialist at AWS. And down at the bottom, you'll see infrastructure, right? And over on the right-hand side, you'll see compute. So when you think about working on AWS, and I was really surprised, I think all of us at from AWS were surprised how many of you actually have worked with AWS before. So I think you get some of these concepts, S3 buckets, EC2 instances, and all that stuff. But when we really look at what AWS is built on compute, right? And when it comes down to generative AI and predictive AI, we have GPUs. If you want GPUs, come talk to us. If you want the latest Blackwell chips to do something, come talk to us, right? All the way down to real basic CPUs. But I think it's really important because as you move up the stack, it's really about layers of abstraction. So when you're talking about developing machine learning models or LLMs on AWS, you can just bring your own open frameworks, do your own open source. That works just as well for some people. But say you don't want to have to work directly with that. And who's spun up EC2 and is running their own stuff there? Is anybody here doing that? A little bit? Yeah, okay. But it's easier to work with the managed services. Let's just abstract away the hardware, right? So our machine learning platform for, again, training, tuning models is called SageMaker. And we've been doing, AI at Amazon.com for 17, close to 20 years now. So it's really just built into our DNA. So that's what we use. We use SageMaker, okay? So that is an ML ops, is the full cycle of machine learning and development in that process. And we'll get more into it, but I really think about it orchestration. So if anybody here is doing Docker containers, anything like that, that's where I really look at SageMaker. SageMaker is ephemeral compute. You don't want to have to go buy a bunch of GPUs and own them in your data center or closet. You just want to go use compute on demand, right? Again, pretty much the AWS business model, on demand. But again, complex to talk to the hardware, manage all those frameworks or whatnot. So think of SageMaker as a layer over the top to help you orchestrate those training jobs, right? So it's only going to chug away on stuff when you need it to. And there's a lot more to SageMaker too, and we'll get into that. The new key service around AI, speaking generally, would be Bedrock. And Bedrock, as I was just saying, this is going to be for you developers that are developing chatbots or maybe back office, agents, those kind of stuff that need access to LLMs. And at its fundamental core, I like to think of Bedrock as really 3 APIs, okay? You're gonna have invoke model. So behind the scenes in Bedrock, you can get access to the Claude models, the latest and the greatest. You can get access to our Amazon Nova models, DeepSeek, open sources of GPT. Oh, am I? Okay. All right, we have to stop a screen share. It's funny, I shared it and then looked up there and said, good. Okay, thank you. Okay, so that was for the remote attendees. So So where was I? So Bedrock's an API. It's primarily what it is. You're coding away in Python or when you need access to a model, a few lines of code off of AWS. We have a whole fleet of models out there. Open source models, we call them third-party models, as well as our own first-party Nova models. So who here has built a chatbot? I saw some, okay, you have, okay. Some of this, a little bit, okay, just curious. But that's what Bedrock is going to be for, okay? And then on top of that, even further abstracted, so say you're running a department or you have a small work group and you do want a chatbot. I didn't finish on the APIs. So invoke model, real basic API, right? Very simple. One of the other ones is retrieve, because retrieval augmented generation, right? That's how we build a chatbot. We go pull that information from document corpuses or whatnot. That's a very simple API. How do I go tap into a vector store, bring in that context into my chat or whatnot, give it that grounding of information. And then there's a third API that I like to talk about, and that's the Converse API for Bedrock. Allows for easier conversation development. Again, chatbot use case and whatnot, streaming responses, that can all be important. But again, we're talking about layers of abstraction. So when you think about what Bedrock is built upon, it's built upon all that compute that makes AWS what it is today, okay? At the top layer, where I was just getting to, say you do just want something more out of the box, that would be off the top layer. We have our Amazon Q, that's an out-of-the-box chatbot, as well as we have IDEs too. So Kiro is our new Gen AI IDE. I don't have a development background, so who's app dev or developers here? Okay, a number of you. Okay, yep. Yeah, I don't have that developer background, so being able to get into something like Cursor or Windsurf or Kiro just to quickly do POCs or build applications, it's amazing. So if you're developing today and you're not using a code assistant, or if you're not a developer, if you're a business analyst or you're working with data, you should go get a code assistant. It makes this stuff so much easier. Like all the stuff that you're deploying into your accounts just a little bit ago, you can just do that from essentially a command line, deploy infrastructure, set stuff up. It's really amazing. I spend almost all day in some sort of code assistant just to get my daily job done. Somebody sends me a problem, need to tear through like SQL statements, SQL definitions. So out of the box. So again, I just like to think in layers of abstraction. So 4 years ago, actually I should probably say 2.5 years ago, this is what the stack looked like. We hardly talked about all the other AI services that are available on AWS. But what you'll still see in there is SageMaker, right? Now SageMaker has just kind of been parked down into a little bit of a corner because just the portfolio changes. But something to note, when you're working on AI projects, you need a machine learning model. It might be an LLM or it might be more a predictive model. Go see what's out there. On AWS, we have a whole bunch of pre-trained models, computer vision, object detection, text extraction, entity extraction. So really look at what am I trying to do and go see if there's a model out there that already does, it's already been designed. So then you just bring your data and train it. So really the message that I look at in that regard is we're gonna meet you where you're at. So today's going to get a little bit gritty. We're going to look at some Jupyter notebooks. I don't know if anybody here works in notebooks to run code or whatnot. I got a guy down here who's a lot of smile and nod. I love the guy. Who planted this guy? He'll keep feeding me with the positive feedback. So depending upon where you're at and what you're building, AWS is going to have it. So if we look under the SageMaker tier there, you're going to see SageMaker Canvas. That is literally a no-code machine learning environment. So you have a bunch of tabular data. And again, the use case I have in mind here would be security data, pulling stuff off the wire. We're looking, threat detection, intrusion detection, IDS and those kind of systems. Lots of time sequence data and tabular data. Where can I pipe that through and do inference on? Well, if you don't want to have to code anything up, there is Canvas. So that's for the business analyst personas, and it's got a bunch of pre-populated models and algorithms in it. So again, all the way down to if you just need bare compute, you want to connect your cluster to it, your HPC and Slurm or whatever, we can also service that too. Other things that you can do within SageMaker, you can't have an AI project, even a Gen AI project without data. So that's where you'll see things like ground truth. It might need that you need to go out and students are great for this. Hey, I got a project, I want to do something, I need to go get data. So let me go collect data from other students. So ground truth helps with that labeling. You need good labeled data, structured data for supervised learning. Okay, a lot of LLMs and that stuff is more about unsupervised learning, but sometimes you actually do need those data. So that's where you're going to see things like ground truth and feature store for actually storing those things. And I think the last thing I want to touch on this slide, you'll see Studio IDE. So where you are working in a web version of VS Code, we're going to be working within a web version of Jupyter Labs, okay? That's going to be our development environment today. But that's an important part of SageMaker, actually, because what you'll run into is you'll run into machine learning teams, again, whether they're doing generative AI model building or predictive models. You need a place to actually code and collaborate. A lot of experimentation happens locally, but that only scales to a certain degree. So with Studio IDE, it's a place to collaborate, share disk volumes, share your notebooks, and also just lives in the cloud, so you don't have to worry about working off a local IDE. And again, I tend to switch back and forth depending on what I'm working on. You know, am I going to use Kira locally, or do I want some sort of web-based Jupyter notebook that I know is just going to be there regardless of where I log in? But anyways, hold that thought on Studio, because we're going to be popping into that here shortly. So any questions on the stack? I mean, there's a lot there, but any questions from the group? Quick pause. Nope, okay. So when we think about a typical machine learning lifecycle, unfortunately this slide doesn't represent the whole thing, but what are you gonna start with on a machine learning a machine learning project? You're gonna have your project statement. You know, let's define our business goals, but as soon as you start to work down from that, what's the next thing you're gonna need? Like, okay, I'm gonna need some data, so let's gather that. This little bit of a flywheel or workflow that you're seeing here kind of snaps in the middle there. But when you think about AI again, they tend to be just these circles that you go around in a positive way. And if you're building a chatbot or Gen AI and doing more AI engineering, those concepts are still very relevant. You know, you want to get your feedback from your users. You know, is my data doing what I want it to do? Is my application logic doing what I want it to do? So it's all about those feedback loops. So within that broader AI lifecycle, there's that orchestration for actually building your models, training your models, and then let's actually deploy those so that they can be used. So that's really what this represents. And somewhere in there is something that I often miss. I'll start training a little model, building a little model, or tweaking an LLM, or doing my prompt engineering, and I don't track it. So after 20 iterations, it's like, man, what were my parameters that worked really well, but I've already lost them, right? So you'll see that arrow down there between build and train, and we'll look a little bit at that today, is how do we actually track our experiments using MLflow? And sorry, I just got a dry voice, so you just have to deal with it here. And then from there, we want to be able to share, you know, under the build section, share our notebooks, share our models, share the artifacts. So once you develop a machine learning model, we're going to actually register it and allow others to access it. So again, just think in those life cycles, and that AI and ML, there's just a lot of repeated processes in getting feedback. Okay, so use cases and also built-in algorithms. I touched upon this briefly, so you don't have to spend a lot of time on it, but from where you sit today, you know, and the studies that you do, you can probably pick out some use cases that extend beyond Gen AI. I think what's really fantastic is actually using AI to ideate, you know, generative AI, ideate on the problems, you know, help you select more predictive, cheaper, simpler, faster models to actually solve a problem, versus just, you know, everything's kind of, we all got this hammer, you know, right now it's called Claude. I bring it to every problem first, but sometimes like, there might be a cheaper way to actually solve this, right? Especially in the security space with so much rapid streaming information. So kind of a fun one just to ideate on. Anything resonate with people up here? A little bit? Yeah? Something? All right. So anyways, lots of models pre-developed. Go take a look. And all this stuff too is we're throwing a lot of information out there. AWS does have very good documentation, and everything that we're putting out there today also we can send you the slide decks, or you can find other versions of it. So how do I actually work with SageMaker? As I talked about, you can just use an IDE. You can use a web-based IDE. We're going to use one, you know, Studio out of SageMaker itself today. It's a SDK, okay, SageMaker SDK, so we can import that into any sort of programming that you're working on. We can also build it into back-end systems. So when you see customers doing machine learning at scale in business processes, they'll often tie a model in that they've trained on a platform such as SageMaker, and then bring it directly into that other application. So our Elastic MapReduce is a good example of that. You can plug it in. So really, you can interact with SageMaker, as I was saying, just about any place. No code, load code, already to bring it into databases that can actually incorporate those models into their processes. Okay, so we're not going to spend a lot of time on the data component today. We are actually going to run some notebooks. And those notebooks are going to create our data for us. But just some things to put in your mind is if you start working on larger projects, or maybe you already are, you might be able to get that done just in your IDE. You know, let's do our feature engineering right here. Let's go get an open source data source or generate our own data. But when it starts to get to be a certain size, you might need to do more batch processing on this data to get it where it needs to be. This is a common situation that I run into with researchers. Like, okay, we've built our model, and we'll get into what that looks like, but you know, we've kind of got our code, we've got our training scripts and all that stuff, but boy, I need to do a lot of transformation on a lot of data, and it's taken me days to crunch through that. So again, just more from a paradigm and a way to think about it. So within SageMaker, and again, when we talk about SageMaker, you're really talking about container orchestration. We actually have data processing containers where if you have a script that's working in your notebook or locally, and you've kind of tested it out and it works well, we can take that script and combine that with one of our containers to just crunch through a whole bunch of data all at once based upon the EC2 or the compute size, depending upon memory or GPUs that we can assign to it, okay? So it's a quick way to get through data. That's one way to do it, but we also have AWS Glue and Elastic MapReduce. Again, think Spark if you're playing with any of that stuff, or Hadoop. Those are those massive scale data processing engines. So if you ever find yourself waiting for data, you know, those ETL type of workloads, look to these other services, okay? But for today, luckily, our data, we have to do a little bit of data work, but it's just gonna be all, you know, prescribed for us, and we'll generate data and work through some use cases with training models. But keep these paradigms in mind, you know, batch computing, those kind of things. All right, training options. So again, we're talking in concepts here, okay? So there's some paradigms that we're gonna need to hold on to, and we'll probably come back to this slide when we jump into some of the labs in a little bit. But there's really, you know, we're talking about pre-trained algorithms or algorithms that are ready to go on AWS. So that you don't have to build your own training script, okay? What you need to do is just bring your data, and we're gonna put that into an S3 bucket, and then we can point one of those pre-trained algorithms, container algorithms at it, and it's automatically gonna do it for us. So it's essentially just to bring your data model. I think that's highlighted in black. I really like the screens in the back corner here. That makes it easy. I can just look up there. There's always this propensity to look behind you. So when you look at the black boxes here versus the things that are shaded in purple, that's what you own as the end user or as the machine learning or the data scientist, okay? You just bring your data, and then the artifact that you get out at the end of it, that's your model. But that doesn't always fit the case, okay? Maybe you need to design or build your own training script. So that's where we can bring our own custom script, and we're gonna take a look at that. It's pretty fun. You can actually design your own CNN or convolutional neural network, get that all structured, and then we can bring that to the container and that ephemeral compute I keep talking about, and it's just gonna blast through it. So in that case, you own the data, the actual training script, as well as the model outputs. And at the end of the day, not uncommon to run this also is if you have some odd framework. And I should step back too. One of the reasons we're able to do that is because there's a handful of common frameworks and softwares to develop machine learning models, again, be it LLMs or more predictive small linear regression, gradient boost models, and all those things. Common frameworks, so we've just pre-packaged Docker containers with all that to make that easier, just so you can just zip through things. But again, sometimes you run into some odd framework, something like that, so you can bring your own Docker container. As a data scientist, you've created this thing that does everything you want. Well, bring that to the cloud, because if you need more compute, that's where you can plug it in and run it. So again, there's the pre-packaged algorithm. Again, this is just, hold on to this one, pre-packaged algorithm. There's the bring your own script, you know, customization, and then we can also bring our own custom Docker container. As well as there's a whole marketplace of models out there too, okay? So again, who's developers here? We had a handful? Okay, great. So when and the reason I asked that is because we are gonna get into the code, okay? And this is pretty standard pattern for developing models. We have to define an estimator. And an estimator is essentially what's the structure of our model, where's that model gonna come from, are we gonna download it from a model hub, or again, are we actually gonna define that model ourselves? You know, just in Python code, we can actually create a model and what that looks like, how many layers, and all the parameters that are gonna go with it. And once we define that actual estimator, we're gonna call it fit. And we're doing this in Python, but we need to fit the model to the data, okay? So this is where we actually bring the data in, we crank it through the estimator, and we fit it to that data. And then from there, we have a model object. I think some of the lines on this are off, in my opinion, but there's a little bit of a chicken and an egg here. But once we have our model, okay, that actually exists as files, then we can deploy it to an endpoint, and that's where we do our inference, okay? And again, all this, you can do this locally in your own scripts, as well as in the cloud. It kind of just depends where you're at. It's kind of common just to run some of the stuff all on local notebooks. Looks good, then let's kick it up to the cloud and run at full scale for our full scale training, as well as the inference. I'm going to hold this thought right here, and we'll, well, no, we can stick on this. I think this actually does represent well that life cycle I was talking about when I keep talking about ephemeral containers. So when we call our model fit, okay, so that's when we're going to say we've got everything together. We've got our training script, and we've got our data, so we're going to call the model fit, and a couple things are going to happen here. First of all, we're going to instantiate that container, and in the definition of our estimator, we're going to specify what that is. What's the model? We're going to go choose the algorithm or whatnot, or maybe we brought our own. Either way, we're going to spin up some compute. Okay, so from our IDE, we call the fit. That's going to spin up some containers in the cloud, and then from S3, because S3 is our object storage or file storage, then it's going to bring that together. Okay, so it brings our training script. It brings our data up into the cloud, and that's where we're going to actually crunch through the data. So another core concept, again, this extends well beyond just training on SageMaker, large volumes of data. Okay, so there's a couple ways that you can bring that in. Sometimes the data that you need to actually process is going to far exceed the underlying volumes of those compute instances. Okay, so the first case that you can do is just file mode. Let's just copy all the data down, wait for that to get copied onto those containers, and then let's start cranking through it. Again, we're talking about model training here. It doesn't always work that way, especially when you start thinking about large language models and how much data it takes to train those. I mean, terabytes and terabytes of data. That doesn't work. You can't wait for all that data to be downloaded to a disk to then process and do your model training. So the notion to keep in mind here is you can actually stream that data in to the models while they're training, okay? So key concept there. We're not actually going to get into that today, but if you get to that scale of model training, generative AI or predictive AI, critical point. So file mode, just download it once, crush it, otherwise stream it in. Oh, one of these slides. Hyperparameter optimization. Okay, so it doesn't sound like there's a ton of data scientists in the room, but if you were, the one thing I would tell you is that if you're using the SageMaker SDK for model training, we do support your hyperparameter optimization. So what does that mean? Is when you train a model, you give a bunch of parameters, and this is where experiments come into play, okay? How many layers? What's this? What's that? What's my dropout? What's my loss? How am I going to measure this stuff? You run one iteration, you evaluate it, not great, let's do it again. Let's tweak some dials and knobs, okay? But see, I just want to just do that all at once. I want to set some ranges of loss functions and whatnot, and what's my evaluation metrics. You can set those ranges and then kick off a whole bunch of jobs. And based upon how those jobs are doing, the algorithms, there's another algorithm that rides over the top in hyperparameter tuning that's going to evaluate those outcomes, and it's going to automatically launch new jobs based upon the outcomes from the previous job. So Bayesian search is a very classic way to do this. There's grid search, random search, all that stuff. But just know, you're sitting there training a model and you have to keep manually launching these things, trying to experiment with what parameters, hyperparameter tuning or hyperparameter optimization is what allows you to do that en masse. Big scale training, data parallelization, model parallelization. Again, if you need massive clusters of compute, and that's all plug and play on AWS. Okay, and we're getting there. We're gonna get the hands on here pretty shortly. Deployment options. Again, another paradigm to keep in mind. How am I gonna process data? We're just talking in the back corner, batch. I'm kind of skipping around here, but a lot of people think that they need a real-time API or real-time streaming. So just to step back, we've built our algorithm, we've trained the model, and now we actually we wanna invoke it. Right, going back to invoke model, or we want to call this thing. We need to host it someplace. So again, you can host it locally. You can host it on an EC2 instance, server in the back closet. But say it's a spiky demand. It's not always being accessed. We can use serverless for that. So you don't have to worry about any of the compute at all. You just send a request, and you'll get an answer back. That works well. It costs a little more. Real-time inference. I think that's the one at the top. Yep, real-time inference. That's actually EC2 or compute instances that stand behind your model. So you say, hey, I'm going to deploy this model, and I want to pick the size of the compute, be it CPUs or GPUs, that's going to stand behind it. And there's cost, latency, those kind of concerns to actually pick the instance size, what kind of chip or whatnot. But that's the real-time instance, real-time instance. What I really wanted to highlight is batch. I think people miss this concept a lot. Say it's a document processing workload or some analyzing transcripts, and you can do that overnight or once a week. It's a lot less expensive in the cloud to do batch operations whenever you can, okay? And this can come down to generative AI also. Bedrock supports batch inference as well. So whether you're using SageMaker to stand up a real basic ML model, and again, SageMaker actually supports LLMs, and we will launch some here in a little bit. But with Bedrock, you can do the same. So you want to just do some sort of detection over a bunch of documents, or look for a checkbox, or analyze images. If it can be queued up at night, do it. Much more cheaper, much more efficient. So again, just paradigms to keep in mind. And asynchronous is somewhere between, in my opinion, between real-time and batch. It's a queuing mechanism where things will eventually get processed. But the nice thing is, it does use actual instances. You can put 10 instances behind it, get a bunch done at once, but then it can also scale down. So the auto scaling is all supported at the same time. And I'm going to skip that, and let's get to some hands-on labs. And Archie, you were going to do this part. And any questions from anybody? Yeah. We live? Yeah. Oh, great. So the question was, how long will hyperparameter tuning take? And that's going to depend upon the amount of compute we put behind it, right? Because we can choose our instances and the number of instances for any one training job. It's going to depend upon the strategy. If you do a grid search and you put in, who's good at math here? If you have 3 parameters and they all have 3 options each, that's 9 iterations it's going to have to go through. It's going to go through every iteration. But think, you have to scale that out to exponentially. It can take a long time. So that's where Bayesian search comes in. It actually looks at the output metrics, and it makes guesses until it begins to understand how to hone in. But it's a big depends. How much data do I have? What are my compute instances? How many parameters? So it can take minutes to literally days and weeks.
Another question.
Yeah. Yeah. And do you work with AWS? Yeah. Yeah, so behind the things, if you understand AWS infrastructure, with SageMaker, you have all your compute instances, and you can define an auto-scaling policy on top of your network load balancer or whatever stands in front of that. So you can set those parameters, scale down to 0, scale up to max. Yeah, so it is very much auto-scaling. Just literally think of it like containers, VMs, however you want to. That's the mental paradigm.
Any other questions? Okay, then we'll be starting the workshop. How many of you were not in the previous workshop? Okay. So, yeah, you already know it's going to be similar, that you will be joining a similar link. You can scan the QR code, or you can go to this website, catalog US East 1 workshops.aws.join, and enter the access code.
And we'll pause here a long time so everybody has the access code. And maybe somebody at the table write down the access code.
Yeah, it's a good idea to take a picture as well.
This goes a lot easier than this morning. Second time's a charm. Thank you, Darren, for taking the hits on this one. Get us familiar with it.
So I'll copy the access code. So you should do something. When you log into the catalog workshop, you'll be asked for your email ID. So put in your email ID and you will have an access code. And once you enter that access code, you will be able to put in the event access code. And I click agree with the terms and conditions, and you can join an event. So again, Kai will be guiding you through the labs, and we'll be following the labs, I think 1, 2, 3, 6, and 7. So we'll do as much as we can today.
And a quick note on the labs that we're going to use is specifically going to be like 1B. Like every section, we're just going to pick one of them out of there, run through the notebook, pick it apart a little bit, look in SageMaker and see what actually happened. Because we're going to drive the workshop through code today. But keep in mind, there's also the low code option. So if you want to go there, like you'll see, I think lab 1A is Canvas. That's a low code, no code. That's actually a slower way to do it. So that's why we're going to use notebooks to programmatically execute things in the cloud. Better way to operate with the cloud, frankly, once you get familiar with it. But we'll pick out the labs one by one and walk through them real slowly. So our sheet's kind of gotten us here. You know, how are people doing? Are people getting in? Want to make sure everybody keeps up.
Is everybody at the AWS console? Yeah. So what we'll be doing is just searching for SageMaker AI, and you will see the option Amazon SageMaker AI. And we'll be opening the SageMaker Studio environment. So click on SageMaker Studio. On the left, you will see options for SageMaker applications. So you will see SageMaker Studio. And the region is North Virginia, right, for this workshop? Yeah, the region should be North Virginia. And we'll click on Open Studio. So you should already see like a user profile that says SageMaker user. So is everybody at the SageMaker Studio console? We'll click on Open Studio. And you'll completely see a new interface and a new console for SageMaker. So we'll click on Skip Tour for now. So just quickly about SageMaker Studio, it's like an interface or command center for where you can launch your Jupyter notebooks or preferred IDE, and you can access the SageMaker AI tools where you can build, train, and tune or deploy models. And it also has a fully managed code editor and some other applications. You'll also see Canvas. We won't be covering Canvas today, I believe, but Canvas is more like a no-code option as well for running your SageMaker applications. So once you're in SageMaker Studio, click on Jupyter Lab. So we'll be doing most of our, we'll be providing, the code is already available in the workshop, but you'll be running your SageMaker train, tune, and deploying models in a Jupyter Lab notebook. So we'll click Create Jupyter Lab Space. And in the name, we will put SageMaker IMD, SageMaker-IMD. So we'll click on Create Space. So it will take some time, and within a few seconds, you will see this run space option. So before you click on run space, we will provision compute for that notebook. So we will be selecting ML M5 2x large compute instance. So let me. Oh, you have a question? Yeah. You have it? So we'll be selecting ML M5 2x large for the instance type. And we'll provision a storage of 50 gigabytes for the Jupyter space. So this space is more like a storage container where you will be creating your applications and attaching your applications. So we will, once you have the settings, we'll click on run space. Is everybody at the point where they have started running the space? Okay. Oh, hey. Wait. I think you're not audible when. Just give me a second. Hey, Akshay, can I have you? Venu is trying to communicate through the channel, but probably the voice won't be coming from the top. Oh, no. Yeah.
If you were in this workshop, sure that you are logged out of that account.
Yeah, that's what. So he tried to communicate. Okay. No, they don't need chat. So yeah, we are waiting for the people on the Zoom call. So we are waiting. Where do we go back to? So just to repeat, I opened SageMaker AI on the AWS console. And when you go to SageMaker AI, you click on Studio on the left. bar, and you just click on Open Studio. And you will see a screen like this with a new interface and a new console with Jupyter Lab as an application. So we'll be opening Jupyter Lab and creating a Jupyter Lab space. And when we create a space, we'll be choosing instance type as ML M5 2x large and storage as 50 GB, and we'll be launching the space. Yeah. Akshay, we are good on chat? Okay, so after Studio, they just need to, once they open Studio, they need to create a space in Jupyter Lab. So on the left, you see a icon for Jupyter Lab. So when you click on that, you click on Create Jupyter Lab Space. So once we have started the space, you will see that the status is running.
How many people's instances have started? Okay, how many people are waiting for their instance to start? Okay, let's just give it a little bit of time. It could be because we're launching a bunch of compute all at one time. So let's just see if those shake out. Oh, and we could actually take a break. Take 5 of those boot up.
Okay, let's wait for the space to get created, and we'll take a 5-minute break and meet again.
Good right now. I have
Oh, what's that? Oh, okay.
Yeah, I'm just doing the window. So show of hands, how many of you were able to successfully run the space versus for how many of you it failed? I want to see the failed numbers. Okay. There are a few. 3 people. Oh, okay. Yeah. So if the instance fails, just redeploy again. Just try it again. Yeah, it should work. Oh, okay.
So who still does not have an instance provisioned? Looking good?
Yeah, Kai, we are waiting on Zoom.
Okay.
Zoom is down. Or do I need to unmute? Won't- Oh, we share. Okay. Yeah, so now as the instances are deployed for the Jupyter notebooks, the next step is if you, we'll be using a GitHub repository that is already available online. And we'll be downloading the content of the GitHub repository where we have the code and like pre-created notebooks, and we'll be downloading and running them on the Jupyter Lab. So in the Jupyter Lab, click on Open Jupyter Lab. And click on Terminal. The bottom you see Terminal, so we click on Terminal and then we clone the repository. So we copy paste that from the instructions in the lab. We are still in the prerequisites part of the lab, just we haven't yet started the lab one. So we click on, we enter git clone. And once it's successful, yeah, and that's it. That's what we need. So you will see on the left section, there's a new folder created for Amazon SageMaker Immersion Day, which has the different modules. And we'll be walking through those modules and those notebooks and running those scripts through as we go through the various sections of the lab. So now I will hand over to Kai to start lab 1. Any questions so far? Is everybody following? Yeah, that's the energy I need. Yeah.
Like it. Spirit.
Cool. So once you have this folder created, we will start the lab. So Kai,
Okay, and we're going to be selective on what we do in this workshop. So there's a lot of material and a lot of notebooks, but I'll guide us through some very specific parts. Because like I said, we could use Canvas, which is a no-code method to prepare your data and get some of this stuff done, but we're going to do it programmatically, a little more fun, and again, a little quicker. But I just want to make sure, is everybody cloned the GitHub repo? We all have that step done. Looking good? Okay, we have our folders on the left. Okay, fantastic. Just going to get, you guys can't see it, but I got a little zoom thing on my screen. Just going to get rid of that. Okay, get that out of the way. One thing to note too, this might have been said by Darren or myself earlier, but all these workshops are actually public, as well as these GitHub repos. And when it comes down to code examples for just about anything AWS, there are loads and loads of AWS maintained repositories out there, as well as lots of others as well for samples. But what we're gonna focus on, we're gonna do lab 1, but the notebook we're gonna choose from lab 1 we can use for both lab 1 and lab 2 to get the points across. Really, the first part of lab 1 is let's generate some data, right? We need some data to do some work with. So that's really what the feature engineering is about. But also within that, so I clicked into the feature engineering and training. And again, I think this is, what part of the workshop is this? There's the workshop. Yeah, so we're gonna do option 2, but we're gonna also use that for lab 2, train and tune. So if you actually just stick along with me, and we'll go slow, right? And we'll just pick this stuff apart. How's our time looking? Yeah, so we're looking good. Yeah, about another 20 minutes is what we'll take to go through this notebook. And I think we can almost just stay in this notebook. And we can flip back and forth too, because as we execute into the notebook, we can go look at what's happening actually behind the scenes with SageMaker. So if you have not worked in Jupyter Notebooks yourself, so again, we went into the feature and engineering and training, and I'm gonna take the NumPy XGBoost. And XGBoost is a very common gradient boosted algorithm, is good for high dimensionality or multivariate classification problems, sequence to sequence kind of predictions. So just think of it, yeah. Multivariant classification, or when I say multivariant or high dimensionality, think lots of columns of different data labels, okay? So XGBoost is very good for that. Our use case today, as we see when we start to go through the notebook, is actually gonna be for, I think it's a marketing personalization, so not quite the security angle. Would have been fun to have more of a security angle on this, but think about trying to predict what somebody's gonna click or accept. So couple pro tips when running notebooks. If you want to execute all cells in the notebook, you can just go ahead and hit this double play or fast forward button at the top, and that's just going to rip through the whole thing. And these notebooks will execute end to end. That's kind of the beauty of them, right? You can set up a process, or even if you're just learning to start to code, I think notebooks are a great way to do it because you can build line by line or build little individual blocks of execution. So if you want to just let that script run, you can just go ahead and hit the fast forward. Otherwise, we can step through the cells with individual play buttons, or if you're highlighted blue like I am here, shift enter, okay? And I can tell you the first cells, there's gonna be some boilerplate. When you work with SageMaker programmatically, you're often gonna see some very common things like the SageMaker session. So as we move through these notebooks, you can kind of just move past those. I'm gonna move past those, gonna import our libraries, and then we're going to check our versions of Pandas. Pandas is a very popular Python library for manipulating and managing data frames. Think tabular data. And I'm just stepping through this, and there's a couple things I want to get to, but right now we're just preparing data. You can also, another thing you can do too, is you can actually collapse sections to figure out, do I have any collapsible sections here? I guess they really just start right here. So this one's not that collapsible. Anyways. We're just going to move through. Let's expose all 19 cells under our data, and let's just keep hitting enter. We're going to define a data set based upon some local CSV files. Not a lot of teachings here. Okay, now that we have a data set loaded, we can actually begin to look at the distribution of data. So this is our normalized distributions. And we can begin to look what's important in our data before we train this model. Do we have bias in our data? Do we have unknown or null values in our data? Does it matter? So data exploration, again, this is not a data science class, but that's what we're looking at in this notebook. We have our distributions. Some of these distributions look pretty even. Actually, I'm going to back up a step to our data. When you go to fit a model, so when I talk about high dimensionality, we're talking about those column labels across the top. When you're doing supervised learning, you're taking a bunch of known examples and you're going to train the model upon those. And one of those features or dimensions, part of that data set is the feature that tells you whether it was the value that you're training for, commonly denoted as Y. So since this is marketing, ad campaign kind of data, we're looking to determine whether somebody bought into the campaign or clicked on something, and it's our Y value that tells us yes, they did, or no, they didn't. So it's binary, right? All the other data is data that there's going to be some patterns in here that'll hopefully tell us who is likely to generate a yes value. But just the thing to note with supervised learning, there's one of your features is going to be the value that you're training to, and that's going to be our Y. Okay. So we'll see that in our distributions. Who said yes? Who said no? Right here, that's our Y value. Okay. Numbers are kind of hard to look at, but we can get our distributions. And then nicely, since this notebook has already been done for us, I'm going to scroll down the visual representation, and it actually tells us what are some of the things that can be pulled out of this data set. So blue collar, married, unknown, those statuses are less likely to say yes to whatever this marketing campaign was. That's just looking at the data, right? So now we want to train a model based upon that data. And what we might actually do is, this just gives us a little more spread on it. The next step that often happens is we want to get rid of some of this stuff. Through the data analysis, we might determine that some values just aren't important. So that's actually what's showing here is what's that feature important and relative to our Y value. Okay, and we've determined that some of them not that important. So we're going to drop some columns, we're going to modify some columns. And I'm not going through those exactly, I'm just slowly stepping through this, okay? And right here we actually now define our model data. There are categorical values in this data, so we're going to one-hot encode those to numerical representation because we can't feed categorical values into our algorithm to actually train it. So we're going to one-hot encode, so that's what our get dummies does. It's a one-hot encode is encoding pandas functionality. Again, more for the data science class, still just prepping some data. Okay. Another concept too when you're training a model such as this, you have that big data set, it already has the answers in it. So if we train our model based on that, then how are we going to actually test it? So we're going to actually carve some of that data out and hold it to the side for our testing and validation. So that's what these next steps are doing. Have our data set, okay, let's just pull some of that out of there. So here we're going to define our training data set, our validation, and our evaluation data sets. Okay, so that was really lab one. Kind of still just getting set up. We have some fictitious data to work with. Again, training a predictive model, but I really get excited about the predictive stuff. I think it's a lot of fun, a lot of use for it. So who has all gotten, who just let it rip from the top? Just hit the fast forward button. A lot of people? Okay. If you're stepping through it, are you caught up to lab one? Any laggards? You guys are on par back there? Amazing. Great. All right. So now we're going to actually get down to, let's actually train our model. Remember what we're going to do here. We're going to push our data up to S3. I think we might have already done that. Pushed our data up to S3. Because when you're working with SageMaker, your data needs to live in S3, ideally. There are some caveats to that, like everything in this world. But data is going to live in S3. We're going to match that data up with an algorithm on a container, and we're going to run it. And again, there's exceptions to that. So let's burn through it. This cell right here, we're going to actually specify our container. You'll see over here at the right, it's the XGBoost container. That's the one that we're actually going to use. Here we're going to define our training input. There's our training data that has the actual answers in it, and then a validation data set. And again, we're using a pre-packaged container. So boilerplate, defining some SageMaker stuff, and here we called the fit, if you guys remember that from before. With this, since we're using a pre-packaged algorithm, we don't have to worry about defining our estimator. But now we have everything here, we can send it. I guess we still do define our estimator. I was wrong about that. And here we specify our instance size. So based upon some experimentation, and a very common pattern here also, start with a subset of your data, a few thousand records, right? Try it on a small instance, get everything dialed in, and then go for the full data set. And through that experimentation, you'll determine what actually instance size to use. So again, experimentation, iteration, dial things in. It's not necessarily black and white coding. It's not quite as logical in that regard. You make good guesses. So okay, so I kicked off the training job, and if you already let your job just cycle through instantly, or you just ran it from top to bottom, you're not going to be able to see this because these jobs train pretty quick. But what I can do is I can pop back over to SageMaker AI. Oh, actually, I could have done this via SageMaker Studio as well. Let's go back over there. I'll try to stick in SageMaker Studio as much as I can. But since we invoked something on SageMaker, we should be able to see the training job still running. Yes, so here's my XGBoost job still running. So it's interesting, again, with SageMaker Studio, we're seeing what's going on behind the scenes, but we could actually step back into the SageMaker service itself, and we also have training jobs represented here. So the message is, you can enter into SageMaker in that environment from different angles and stuff, but what you're really doing is you're leveraging that API and SDK to drive that abstracted compute. So I know my model is still training because I have that little hourglass up there, and we're just going to let it cook for a moment. So here we can see that the container is actually downloading that XGBoost image. So we're still waiting for our compute to spin up. Then it'll actually download the data and process. I think things are being a little pokey just from the number of people we have logged in. Well, that doesn't make sense either, but we'll just give it a little bit of patience. Three minutes? Was that to load the instance or from end to end? Okay. Yep. Okay. So mine has finally started training, and since we're using a SageMaker container with SageMaker SDK in this Jupyter environment, we can actually see the container execution. So essentially a terminal STD out, standard output. And if you have a long-running training job, this job's probably going to be pretty quick since it's going. You can click into the training job within SageMaker, and you can actually go watch the CPU utilization or whatnot. I'm not, we get some tiles of charts and metrics here. I'm not getting those right now. But that would help you gauge what size instance to use. I'm sure there's like or Control Z. Undo should work. Fat fingered it, man. But yeah, I would just. Okay, my training job is done. You get some metrics back, how many seconds that took. So traditional machine learning training can be very linear on how much time it's going to take based upon the instance that you have and how many data points you send in. So if this was 1,000 labeled sets of data and we knew the instance size, it's fairly linear. And that would help us, how long is this going to take at scale and how much is it going to cost me? And then you can balance your instance sizes and offset there. Okay, so literally we've just trained a model, an XGBoost model that should give us predictions based upon our validation data set to determine if somebody can say yes or no. So let's actually deploy this. So we need to get this thing out there. So that's hosting, and we're going to deploy this to an ML M4 X large. Going to take a moment. That's going to create us an endpoint, and I can go back to SageMaker, and I can actually see my endpoint should be creating. Once this critter comes up, we can use the SageMaker SDK to call this endpoint that the model's behind. If you're into containers or whatnot, just think about what you'd put inside a Docker container to host an endpoint of some sort, Flask or whatnot. I'm not sure what these containers use, but it actually exposes essentially HTTP out of the virtual machine. And for those of you that are stepping through the notebook, cell by cell, if you get to the deploy, you'll notice down below the little warnings that there's some hyphens or dashes appearing. It'll continue to do that with an exclamation or a bang when the model's finally loaded. I tend to watch just the upper right-hand corner, the hourglass. So while that is chipping away, a couple other things to look at. When you invoke a SageMaker endpoint, those endpoints are HTTPS. You cannot send raw text through HTTP, so we have to serialize it. So that's why you're going to see a serializer, very common when you're working with that SDK. So you have to serialize it, and then the container on the other side will deserialize as part of what's built into it. But if you brought your own container, if you built your own model, you'd have to build the serializer into that container just to actually so that your, whatever your code or whatever your script is could work with what was sent across the wire. So the hosting should just take a couple minutes to get that spun up as an endpoint. And then what we'll do is we'll throw that evaluation holdout data set at it and look at our values, see if it works. And actually, this notebook does have hyperparameter tuning in it, so we can actually take a look and see how long that takes on this sample. I think it'd be pretty quick. But if we look down here, automatic model tuning. Again, I was talking about with the hyperparameter tuning, you can do random search, Bayesian, and if we don't specify in the actual hyperparameter settings, that means it's going to default to Bayesian search, which is going to be the most effective. Again, it takes its own algorithms to measure the metrics that are defined. In this case, our objective metric, where's our objective metric being defined? Yeah, so going for AUC for a validation metric. Another important note too, something to keep in mind, somebody might have already thought about this, we're training on what I like to call ephemeral compute. So we've instantiated an instance or provisioned it, that's where the training is happening, X large of some sort. So your model weights are going to be saved to that local instance. And one of the things that SageMaker coordinates is grabbing those model weights out of that actual ephemeral instance and storing it into S3. So all your model artifacts, anything that you write out to text files, again, that's all going to be accessible to you in S3. And that's part of the, there's some default paths where you can specify those. Not sure why this is taking so long. Let's see, let's go poke at it. Have others been able to get the inference endpoint stood up? Any success? Any evaluations? Not quite? Okay. There's one? Yeah? Okay, awesome. My guess is we're also just waiting for compute to become available on some of these. Waiting for instances from other resources. Okay, mine just finished. Great. All right, so I'm going to define my serializer and move on through. Let's define our predictor. This is what's actually going to call the model. And okay, here's our results. Here's our predictions. So it looks like I have 100 predictions that people will actually subscribe. And I also have 382 who would have subscribed that we did not predict. So not quite there, right? So we'd want to go back through, look at our training data, rerun, loop through, and again, that would be really nice where we could just make that happen. This cell right here, cell 22, let's delete the endpoint, critical. So if you're playing around training models on SageMaker and you stand up those endpoints, you don't kill it off, it's going to be charging you because it's a compute instance that's running. So while the training was, I keep saying, was ephemeral, not so much the real-time endpoints. So I know I get myself in trouble on that. My boss will say, blew your budget for the month, like has some endpoints that I did not delete. So it doesn't really matter in these workshop environments. That's on us. Let it run. But if you're pulling down some of these notebooks and working in your own environment, always keep that delete cell in there or create a delete cell because that'll actually go terminate the instance. And that's why creating pipelines, which we'll get into, and just running through these notebooks just from end to end that they just complete, that's a real key pivotal point. It really goes from that tinkering to actually full ML ops. Because once you have notebooks, so what can happen is you can have a notebook that actually does all your data preparation for you. That's one notebook. Then we have a notebook that can do the training. Then we have a notebook that can do the actual deployment. And if those all work end to end, then we can stitch that stuff together in pipelines. And that's actually built into SageMaker as well. And we'll get into that here in a little bit. So let's see, what's our time? We're going to do a coffee break. Just keep us honest, 2:45. I'm going to keep going on this. Let's just see how long that hyperparameter tuning job takes. So to do that, though, we need to stand up a serverless endpoint. Again, serverless does not require compute instances. So this is the exception. So like I was saying, go delete those endpoints because otherwise you have some compute running. Serverless is not that case. Problem with serverless, there are some limitations to it. So the algorithms that are supported, the payload sizes, those kind of things. But it's a great route to go if you have something that you want to keep out there from a model perspective, but just use it every once in a while. So I'm going to bust through these cells. Let's get down to this, create the serverless endpoint, get that stood up. Let's wait for it. And there's our wait function. So once again, creating a model. I think this will go a little quicker with serverless. But what happened is since we saved our model, we can now just reuse it in multiple methods. Questions on training models? Something must be percolating. Yeah. So the question was, what percentages to do for a holdout for your evaluation or your value and your validation and evaluation data sets? That's going to depend. Very common splits are 80-20, 70-30. And then from there, it's experiment. Yeah, but pretty common in that ratio. Good question, by the way. Other questions? Gen AI questions are okay too. Next time we could do a Bedrock workshop, build some chatbots. Yeah. The question from the gentleman up here is what kind of use cases or workloads work well for this? Actually, let's just flip back over to the slides. Uh-oh. Where'd we go? Did we just lose that? Or is... I'm not... Yeah. Yeah. Oh, display. How'd you do that?
Oh, probably click.
Okay, so to go back to it, these would be common use cases, primarily predictive AI. But I think there is a tile up here that does talk about, well, I mean, some of these are just, it gets so fuzzy, right? With object detection, you can do that with LLMs. But if you think more traditional AI use cases, that could be something like this, right? We are actually going to do in one of the labs, do a bit of computer vision. It's a very simple use case. It's actually training an object recognition for digits. So how can we train a classifier to pull out numbers or digits? So very common use case. I work a bit with law enforcement, license plate detection, those kind of things. But I would say computer vision is very, very common. Some of more of your text models, intelligent document processing, extracting text out of documents would be a common use case. And also just making a prediction. You know, businesses need to be able to make predictions. What's going to happen next? How do I forecast something? So you'll see forecasting in there, you know, more time sequence data. So it's working backwards from the problem is a very common Amazon thing. You'll talk to a solutions architect or an account manager, and you'll feel like they're going to flip the conversation on you because they're going to say, well, what's your problem? Let's identify the problem first and work backwards and then choose the model. And I'd make another note there too when I'm saying it's become fuzzy between LLMs and those large transformer models and the more traditional algorithms. And maybe we already said this, we're all running around with this big old hammer and it does amazing things. So everything's a nail. And that hammer are large language models, our vision language models. But when it actually comes to enterprise scale and size and affordability, often a smaller model, if you can find one, even if it takes a little training, is going to be much more effective when you're dealing with millions of requests a minute. Okay, so let's check in, see what is cooking in our notebook. Okay, so now off to hyperparameter tuning. So let's define a payload. Okay, so now kicking off our hyperparameter tuning job. We'll see how long that takes. And here, one of your questions on how long would an HPO job take is how many maximum jobs here. I'm not going to let this run for more than 20. Oh, our gentleman left. Okay, topic change. So who's following along still? We lost the audience, or we still got some people engaged? Okay, we're training some models or whatnot. Okay. We are coming up on the allotted coffee break. And we can keep rolling or take a moment. Because what we're going to jump to next, let's just take a look at the notes. Okay, the next one that we're going to jump to would be bring your own script. It is an interesting use case. It is training a convolutional neural network. Great, it's a very common computer vision use case, so kind of fun to see what does it actually look like and define our layers. There's just going to be 2 layers in this model, but it's fun to actually see what happens there. And we had a gentleman here that does some computer vision training. I don't know where he went. He might have exited. Had a pretty cool use case doing image segmentation off of drone footage. This would be a case where you could build something like that. Again, we're just going to detect digits, literally just detect numbers, but again, just to see that process, how you could possibly train your own model. A lot going on in that space. So this will all eventually finish. I do want to see what it takes for our HPO job. And we're doing good on time. So more questions. And again, Gen AI questions too. Talk about RAG, vector stores. Yeah. I think, so the question, if I got it right, is how do we gauge is it the trade-off between model accuracy and cost? At a certain point, you're going to find that you're going to get very small incremental gains for the price, right? At a certain point, if you know your accuracy threshold, that curve, right, is just going to start dwindling. Let's give it more data and good quality data, right? But more good quality table. What is my incremental gains? Is it worth it? But what I'd actually do there then is I'd flip that to a business decision. what's good enough for the business? Is this accurate enough? Like, no, stakeholders come in and say, not good enough. I'm like, well, do you have another $8,000? Nope, that looks pretty darn good, right? So it's balancing those, okay? Yeah, from an overfitting perspective, yeah, absolutely. You can certainly overfit. And that's, again, a little bit of what's the bias in our data. And if you run too many jobs, and that's why you want to continually evaluate the outputs from there. Yeah. I don't understand the question. It'd be the same. It'd be the same conversation. Yeah, it's going to be the same conversation. Yeah, what's the cost of this incremental gains in accuracy and quality of the model? At some point, you're good enough is good enough. Still don't know if I'm quite getting to the question. Yeah. Where are we at? And any other questions too? Again, love talking about Gen AI. We can go there. Yeah. Yeah, and maybe we could get a crowdsourced answer on this one too. It's like, where does machine learning fit as a broader technology? I think it's absolutely pivotal. Look at the success of Amazon.com. We consider ourselves a machine learning. Previously, we considered ourselves a machine learning company. Now we consider ourselves an AI company. But I'm not talking about AWS. I'm just talking about AWS, Amazon.com. Predicting, what's that next recommendation for a product to purchase is invaluable. Think about logistics, forecasting, shipping, time to delivery, order selection. You don't want things sitting on a shelf unless you absolutely need to. So consumer demand, imperative. Let's take it outside of commercial. Let's talk about healthcare and life sciences. Pandemics, flus, COVID was pivotal during that time to get those metrics and that data from the people. Who's getting infected with COVID? How fast? Where do we need to worry about this? What populations are at risk? So to me, from a technology perspective, I think AI is very important. It's been behind the scenes all along. It's just Gen AI that's really brought the conversation forward. And that's why I encourage people to not just look at generative AI, but look at the predictive things, especially you as students, getting engaged on this. LLMs, super cool. VLMs, or visual language models, super cool. But also, how many other real-world problems can we solve with more traditional forecasting models, the predictive models? Did I answer that a little bit? Okay. Yeah, sure. Yeah, so the question was not necessarily where AI fits in the whole world, but where does AI fit in, or SageMaker fit in your overall infrastructure, application stack, or technology stack, right? So with SageMaker, we can train a model, right? So the output from our model training is a model, and then we can take that based upon its format, and we can bring that to those other systems. So I'm not familiar enough with Hadoop itself, but I know some of those other MapReduces or Spark, right? You can actually call a function from within Spark and do a prediction across, say, a time series piece of data or a sequenced data, right? So that's where this would fit. So we're using SageMaker to actually develop a model as large of, say, a streaming workload. So I would think of, again, there's kind of a security vein to this Symposium. So if we think of a security use case there, I would think of threat detection or intrusion detection. We're pulling packets off a wire at very high speed from many sources. And we have known anomalies or detections that we can train a model upon. Okay, so we've trained our model, we have that. Now we need to actually inject that model into our stream. So I think of, again, Spark. I think of, what's another one? What's a Flink? So if you have a Flink, Apache Flink set up, within that pipeline on that streaming data, you can actually then be passing inference on each one of those time series chunks that you define and whether they overlap or stuff. So I did get closer to it on that one. Okay. Yeah, yeah. And really the implementation, what that looks like within Flink or those other large-scale streaming platforms, Kafka, that was the one I was thinking about, Kafka streaming, it becomes the API call. So what SageMaker becomes is the API that you execute out of Flink. So you actually invoke the model from SageMaker in that processing and streaming pipeline. Very much related to the IoT use cases, right? That's IoT, essentially. Or is another good use case, I think. And do you work with Hadoop yourself and those kind of workloads? Yeah. Yeah. Yep. Yeah, and really that high velocity streaming, that some of that stuff really blows my mind. I mean, how to handle that much data aggregation when you think about some of these home security places and just the IoT and the data that's just streaming in, or video streams and passing inference on it, you know, how to tie those things together. Bonkers. But to the point again, where SageMaker fits in, it becomes the API call for the model inference. Okay, so this is our hyperparameter tuning job. Let's see how long that took. Quick math. 10 seconds? No, 10 minutes. For some reason, this is stalled out here. Okay, so real basic model tuning. Got through that. Probably time to move on. What I'm going to do here is I'm going to click back within SageMaker Studio, within our file explorer here, Windows terminology. And we can go to bring your own model. And let's actually do a vision model. And I'm going to choose the PyTorch script. So again, this is the PyTorch script within the bring your own model. And I'm just going to go ahead and I'm just going to let this thing go. I'm going to hit the fast forward button. Think about our schedule. Okay. Okay, perfect. 2:45-ish. I went ahead and kicked off the bring your own script notebook. So if you guys want to do that too, then let's take 5 or 10. Coffee break, if there's coffee. Hopefully there's coffee. I need coffee. Long day. Okay, so see you back here at top of the hour, 3 p.m. You guys want to get back to it? A little more? I didn't refill my coffee cup and I should have. You guys are still engaged. You're here. Very common to start losing people as the afternoon goes on, too. So, happy to keep it engaging, ask questions. All right. So, like I said, I was just going to run, and I did run this notebook end to end. This was essentially a classification problem, image classification. So let's just step through the notebook. It should have executed. Looks like it finished. The one thing doing it that way, we're not going to be able to go look at the training job because that was ephemeral. That one's gone and dumped. So what we do here is we zip out to the internet, grab a MNIST sample data set. It's really just a bunch of numbers, and it's pre-labeled for us. Very little data transformation on this one at all. It must already come with our holdouts, but we're going to upload it to S3. So that all happened. That's great. So here's the difference, though, is you'll notice that we actually printed out the training script. And yeah, this happened. Sorry, this little flash right there. That's always a little bit of a nightmare. But this is where we actually define. I was just talking to these guys over here. They've been training their own neural networks for an audio use case. Super cool. This is where we actually define our layers. Very, very simple CNN here. Okay, but that's a basic construct what it would look like. But what did we do? We didn't find a container that had an algorithm that we wanted, right? We went and shopped. We looked at theirs, like, nope, I need to build my own. So we created a training script. So this is literally what one of those things looks like. How long was your guys' training scripts? You have your own training scripts, right? To build your own. How long were those? In Python or? Pretty long? Okay. Yeah. So again, that demonstrates how simple this particular training script is. Under 50, but your training scripts can go 500,000 lines of code, okay? This is defining your layers, all that stuff. So what we did in this one is we took our own script and we're gonna combine that with our inference container, okay? And when we define our inference container, we can choose our Python version, other libraries that need to be essentially requirements.txt. Key point here for you guys that have done some model training, where is our save? There should be a function in here that shows, there's our train function. There should be there's a test model function, save model. So if you were doing this on SageMaker, you would need to make sure you had a save model function that output those weights to a very specific directory on that container, and that's where SageMaker is going to suck that out and dump that on S3 for you. So key point if you're actually doing SageMaker training with your own script. And again, this is all very well documented, but that's a highlight here. You need to write out those model weights so that they can be retrieved. Because if you don't do that, when the training job's over, well, everything just got deleted. Okay, so we ran our training job. Okay, so here we actually defined our entry point. That's when the container loads and we send the job to it. We've defined the entry point, which is our actual training script. Defined our instance size, good old traditional C5 2XL. We gave it just one epoch and used a glue black backend. Then we called our fit. That worked great. Okay, so this last cell, so let's get down to it. We actually called a predict after our model training happened. And with the predict, then we can look at our results. So it looks like for this instance, for this particular prediction, number 3. That's what we got out of this. So most likely answer is number 3. So for whatever image, I thought this notebook, and some of them actually do, this one doesn't. It'll actually print out the image so you know what number you're actually, or what that actual digit looked like. You'd actually get that little PNG or JPEG file. This one doesn't do it. So we're taking it on faith that it got it right. Anyways, that was a bring your own script. Any questions on that? Okay. How's people's energy doing? Are we going to run this to 5, or is that just holding on for dinner? Okay, this guy's going. All right, do a couple more. I'm paid to be here, and I like being here, so I'll just keep going. All right. I see some smiles. Had some good career questions too. Who from the AWS side is good on the career talk? Aaron. Also, we can have some questions there. I don't know where Archita is. I'm deflecting at this point. So for those that do have career questions, or where you go or what's working, just hit us up individually. Archie's like, somebody call my name? Oh, I just say, there have been some career questions walking around the tables. I don't have a specific one now. I was just pointing out the other AWS folks to ask them, what worked for them, questions like that. What was your path been here? Oh, yeah, you can tell it now. Yeah, tell a story.
Yeah, that's an interesting question. So just like you all, like some of you all, I was a university graduate when I joined AWS. I did my master's in computer science at Santa Clara University in California. And I joined as a cloud support. I didn't join as a solutions architect. I joined as a cloud support associate. So I was really new to AWS when I joined. I joined like a student training, as part of the student training program. But like I was new to AWS, and I was like, AWS, it's not like they are gonna give you baby steps. I was thrown into like troubleshooting network firewalls, logging network errors, or learning about on-prem, how does on-prem networking work, Wireshark, packet capturing, everything, and about the AWS infrastructure, how VPCs work, etc. But that kind of accelerated my training. But at some point, I realized that, yeah, this is a great job when in terms of my technical depth. But I'm very focused on like a specialization. And when I got into AWS, just like you right now, I was so curious on what's going on with AI, what's going on with machine learning, containers. I wanted to learn about the whole infrastructure. And also I like talking to customers in general. So I felt like I should switch my careers and become a solutions architect, where I can learn about real challenges in the real world and work backwards from those challenges and think strategically. So yeah, I've been here 5 years now, and it's been a fun job. Yeah. Any questions? Well, thank you. Darren, did you have anything? How's your AWS journey been like?
Are we doing like, what was my career path kind of thing? Well, I'm from St. Louis, Missouri. I went to Southern Illinois University in Edwardsville, which is right on the other side of the river. I did my undergrad and grad in computer management information systems, so it's kind of like a hybrid CS business degree. Originally, when I graduated college, so I interned at Illinois Department of Transportation for 2 years, primarily doing networking and security. Graduated and did networking and security, and I did that for about 8 years. I'm old. And then I was a Microsoft guy for a long time. I did a lot of Microsoft Azure consulting, M365 consulting, and that led me to AWS. When I interviewed for this job, I actually presented a Microsoft architecture, and surprisingly, they still wanted to give me a job. And I've been here for 4 years, and that's me. I think what's interesting about, I don't know, if I had to like give some career advice or whatever, like not all those who wander are lost. Follow what you're interested in. It's okay to like, hey, I'm going to focus on cyber for a couple years, and then I want to get into data and AI. It's totally cool. You want to? Yeah, come on in. We're all sharing. You guys stay away from the speaker.
Yeah, that's it. All right. Story time.
He's a fellow student.
Yeah. I'll talk about that. But yeah, I have like a very funny path on how I started work for AWS. It's not your typical thing where I just went to college and then I just applied and they gave me a job. It was not even close to that. So story time, this is how it worked out. So I went to the University of Georgia for my undergraduate degree in computer science. And while I was there, I had a part-time job working at a private school in the IT department. Basically, it was a one-to-one laptop program. So basically, I worked there to help desk while I was doing my computer science degree. So right when I graduated, I thought that I would become a software engineer and that would be my path. But lo and behold, my boss quit, which was the head director of information technology. And since I graduated, his boss above that said, who could we get to fill this role? Brian. So straight out of college, I was the director of IT. And you know what I did on my very first day? I took down the DNS of the whole school. So basically the school network failed because of me on my very first day. And I thought they were going to fire me. But lo and behold, they kept me. So I ended up working that job for about 9 years. And at that point, I got a master's in education. And I thought my career would be in education. But I was doing software engineering on the side to make extra money because it didn't pay very well. So I decided to leave. And I was trying to figure out, what do I do in life? I had all these skills. I was a developer. I ran some infrastructure on-prem, but I had no idea where my life was going. So I did some just random thing. I just started going to meetups. You know those things where people go, like meetups and stuff? So I started going to meetups, and I started bringing my resume to meetups and just attending any kind of meetup to learn about new technology. And while I was there, I met a recruiter, and he said, I know exactly what you are. I was like, what am I? He said, you're a DevOps engineer. I was like, great. Now, what is that? So, so I started looking for jobs that were a DevOps engineer role. So lo and behold, there was a startup in my town in Athens, Georgia, called Seller Labs. And basically, they ran AWS infrastructure to scrape Amazon.com, essentially. Basically, they were scraping Amazon.com. They did incentivized reviews. And basically, they had created a SaaS product around that. So I said, cool. So I applied for the job, and they were on the fence about giving me the job. So I was like, here's the deal. How about I work for you for free? If you guys let me work for free, maybe you'll give me a job. And I was like, hey, you can't do that. So basically, they gave me a probation period for 2 months. So as soon as I started that job, my boss calls me into his office, and he's like, this is what I want you to do. I want you to deploy this application on AWS Cloud, and I want you to use CloudFormation, and I want to make it multi-tier and scalable, and you have until Friday. And I was like, sir, I can absolutely do that. I just have 2 questions. 1, what's AWS? Number 2, what's CloudFormation? So essentially, I spent like months under my desk trying to figure out what AWS was. Actually, that whole week, trying to figure out what AWS was and what CloudFormation was. But in that experience, I loved CloudFormation. It became my thing. I love infrastructure as code. So I felt that was my calling. And I thought I had secured my place into the universe. Then it happened. Amazon said no incentivized reviews. So essentially, the company's revenue got cut by 75%, and they were laying everyone off. And I worked in a DevOps wing. So I was like, what can I do in order to keep my job? I said, you know what? I can reduce their AWS costs. So at that point, I started doubling down on AWS certifications, understanding the cost of it. I also went back to school and got a master's in computer science while I was doing this to ensure that they wouldn't fire me. And I started reducing their costs so much and to the point where they allowed me to stay for 2 years. And at that point, I graduated, and I learned a lot about AWS. So at that point, since our company was built around scraping Amazon.com, I came up with this genius idea that I would apply to AWS in order to ask the SAs how AWS worked. Because I knew that we had issues scraping them, and we felt like they had some kind of WAF or something. So essentially, my job interview, I was acting as a spy. So they would ask me questions, and then they asked me, did I have questions? I was like, yes. How does EC2 work? Does Amazon.com have a WAF? And basically, I kept interrogating them, trying to get this like inside information. So I had no intentions of getting a job with AWS. I was just trying to understand how it worked, and they offered me a job. No. So we worked for a company that scraped Amazon.com. So basically, we were scraping all the reviews. So they offered me a job, and lo and behold, I've been here for about 8 years now. I've done everything from working on the CloudFormation team to being a partner org. I'm also a student here at UND as a PhD student, pursuing my PhD while working at AWS. So just goes to show that sometimes you can take some crazy paths to get to where you wanted to be. And I think the biggest part about your career is always willing to learn something, because everything changes. No matter what the technology is, they look for people, and most industries look for people that are willing to learn something new and don't let things discourage them. So that's my crazy story. These are Troop shoes. These were very popular in the 80s. So these were original like shoes that rappers and everything really were in the 80s. And this is, if you've never seen Troop, I don't blame you. These are like the original thing. And they're actually coming back.
All right, a little fun. Thank you, guys. Good to hear. And it's really interesting to hear people's stories. And I think, Brian, you summed it up pretty good. There is not always a linear path to a career. Mine hasn't been. It's always been in technology, but the various jobs and roles, from manager to help desk to just, it's circuitous. And it's just that passion about technology that'll lead you on. And what you're doing today and what you envision today, that could be, and not just because of the rapid pace of development, but that could change and go with that. Don't get stuck on that one thing, but just being here and learning and then doing, that's what it takes. That was a kick, though. And always worry for we're open to other improv as well. So other people have topics or things they want to talk about. Or use cases. I would say that too. That's often an invite I'll give. If somebody has a cool project here and you don't know everybody in the room and you want to share it, come up here and, talk about it. Just push me out of the way. Okay, so let's just do a couple check-ins. It's 3:20. We have till 5. Kai does not need to talk till 5. We are going to do some fun model training. Archie, you said you were going to do the jump start, right? Should we actually just, no pun intended, jump to the jump start and do a little bit of LLM work? And then based upon time, yes? Okay. Yes, let's do that after jump start. Okay, yep. So we're just going to skip that one real quick. But Archie's going to do. Yeah, let's do. Yeah, we'll do MLS at the end. Yeah. I don't know where I am.
Yeah, okay. That's fine. It's anyways a different.
I didn't know.
No, I think, actually that's fine. Thank you, Kai. So we'll be jumping on to a very interesting session, which is like a hot topic right now with like so generative AI models. And we'll see some fun fun labs where we'll be prompting, sending some prompts, but we'll also be like not just we'll use existing models, we'll prompt it, but we'll also like use hyperparameters and parameters to fine tune it, and then generate some summaries and also like images using these models. So to start with like what Amazon SageMaker Jumpstart is. So we'll be going through the Lab 7 section, and SageMaker Jumpstart is basically if you want to get started with machine learning and want to use like pre-trained models that are available on Amazon SageMaker. Amazon SageMaker has like more than 150 pre-trained popular open source models, which can be used for like natural language processing, object detection, image classification, and with like without like provisioning infrastructure or doing a lot of scripting, you within like one-click development deployment, you can launch these models. And you can also fine tune the beauty about it is like if you have heard like these popular models, right, or applications, uh, you sometimes don't have the flexibility. You just get what is out of the box and you run prompts on it. But with SageMaker, you can find because of the programming approach, you can fine tune these models and train and tune and even train and tune these models for your research before deployment. So we'll start with, we'll summarize a document, and we'll be deploying Llama 7B, which is like a popular open source model. We'll deploy that and we'll run a summarization chain using LangChain. So how many of you have heard of LangChain? Yeah, there's a lot of you. And LangChain basically provides you more like a framework, which is like an open source framework to build generative AI applications and makes it easy for you to build these applications. So we'll start with our lab. So to deploy our model, and we'll first like invoke the model, deploy it, and run inference on it at first. In the second lab, we'll fine tune the model and run inference on it based on that. So we'll start with the text summarization. So navigate to your SageMaker Studio environment, which Kai already brought you here. And we'll be choosing Jumpstart. So if you scroll down in the features section, right where you ran your training jobs or evaluation jobs, there's an option called Jumpstart. And as you can see here, it's like a attractive picture of the AI models that SageMaker Jumpstart, and you can pretty much see like popular AI models that SageMaker Jumpstart offers. So we'll be choosing the Open Llama 7B V2 model, and which is predominantly used for text summarization. So just search for Llama 7B. And if I see it here, there's Open Llama 7B V2. And just select it. So we keep everything default and click on deploy to deploy and create an endpoint for your Llama model. So we click on deploy. And again, as it's an endpoint, we'll need to choose a compute instance to run this model. So within a few clicks, you're deploying a model on an AWS infrastructure without doing a lot of programming for that. And we just keep the instance as default. Let's see. On the bottom right, and on the bottom right, we'll see the deploy. So click on deploy. So it takes a few seconds to deploy the model, and you will see the status as creating. And we wait till the status is in service for the model. So any questions so far while we wait for the model to deploy? Is everybody at this tape right now? So this is more like a large language model. And in the next step, we'll be following a summarization chain using LangChain. And again, similar to the previous labs, we'll be running these on a Jupyter notebook. And we'll be showing some, like throwing some prompts, some parameters, and based on that, we will be generating an output. So while we wait, like what are some popular or non-popular, like whether it could be for research or any kind of use case, like chatbots? What have you all used? Like what models have you all used? Claude? Yeah. Anything else? GPT? Has anyone done any like model comparison on which performs better for which use case or so what did you see like in terms of like which is better or what or is it like different for different use cases? Yeah. Much more improvement using GPT? Yeah. Okay. Okay. Yeah, that's good. So what you said is like more training data or more parameters it has that performs better or yeah. 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 Yeah, we'll also look into like ways where sometimes the parameters can make the model be very creative versus like being very fact-based. And it can be, you can set up a parameter which is called like a top K parameter where how much data, like surrounding data do you want it to consider before you train this, right? So if you put your like the data, if your data points are more, you'll probably have more creative answer, but it will be more, it will feel like more like a cognitive interaction, but it will also probably deflect more from like actual fact-based data. So you can set those parameters as well, like if how much data you want to consider, how accurate you want the data to be versus how creative you want the outputs to be using these parameters. It takes a few minutes. So while we do this, I'll also quickly, like we'll be also be using text to image stable diffusion model. So oh, I see smiles for stable diffusion model. We at Amazon, whenever we have these conferences like reInvent or like local, we have AWS Imagine for education. We always have a booth where people can just come up and do fun stuff where they can use the stable diffusion model to generate like fun images of them. Like I've seen some prompts where yeah, make me look like a aquatic king, right? So the model generates an image where you can look like, and sometimes it's gotten so better, and good thing about stable diffusion models, it can help you denoising the image. So it can help you like your keep your facial features intact while combining it with like creative images. So we'll also be looking at that in this lab, where we'll be generating an image of a dog, but there's something creative about this image of the dog. Let's see. Yeah, so you will see the status is in service for the Jumpstart endpoint. How many of you see in service, or is it still creating? How many of you see still creating? Okay, there are a few. Yeah, we'll wait for that. And in this text to image stable diffusion model, we'll generate like straight up an image using a prompt, but we'll also look at a concept called prior preservation technique. So what it does is, for example, if you just train the data with dog images, like if you want like a poodle, if you just train the data with poodle, you will think maybe that's better, right? Because you have data points which will be accurate. The thing with stable diffusion is it wants to generate an image that is closest to your prompt. So what it does is, if it just has poodle images, it will try to identify unique things about those poodle images. And it may identify something which may not be needed as well. For example, a shadow or a sunlight spot or something. And it will make that feature appear in your final image. So sometimes your data points should be more than what, not just poodles. Like some may think like only training on relevant data or accurate data, exact data will gonna give you better response. It's not always like that. With prior preservation technique, we'll be training them with other dog images as well. So how the model learns is, it's better for it to differentiate the poodle when it compares to the larger data set. So it can, it's called classification. It helps to classify whether among all the dogs, this is a poodle data set. So that's called like a prior preservation technique, where it can identify the poodle among other dogs, among the large data set. So we'll be using that image model. But now we'll move back to text summarization before we get excited about the image generation. Now the status is in service. So once it's deployed, we'll go back to the Jupyter notebooks. If you already have the Jupyter notebook open, we'll go back to the SageMaker Immersion Day folder, and we'll click on Jumpstart. If you see a Jumpstart folder, and we will be using the Llama 7B document file to run the Jumpstart script. So now what we'll be doing is we'll be running through the script, and we'll be generating a summary. So we'll just import the models we need. We'll start a SageMaker session with the appropriate permissions. And the next thing is we want to do, now we have the model deployed. We want to infer from that model. So what we'll do is we are sending a bunch of data, and we are serializing the data and make it deserialize it to make it more sense, so that it can be sent to the model as an input text. I think I made the same mistake that you did. I deleted a text code. So I'll probably, so I tried to zoom out and it somehow deleted the text. So I'll probably redeploy the GitHub. So I'll go to the terminal icon. So you don't need to follow these steps as you already have this. I'm doing this for myself so that I redeploy the GitHub. So I have the module again. Huh? What? Yeah, but I'm trying to figure out. So you deleted the folder, right? Yeah. Oh, it still appeared the same way. So what did you do then? Restarted the Jupyter lab? Okay. Okay. So this one, should I just this button? So it takes some time to restart. Restart kernel, this. Which one? The Git one? Okay. Okay. Okay, got it. Yeah. So I'll have to delete the. Try? You help me. Yeah, yeah. So then, if I have to, I'll have. But it won't affect your ML. But the I'm not able to figure out the right click on this. The first one. Oh, undo cell. Llama.
Also just go.
Just the entire report. I was gonna got it already.
Yeah, you just lean towards that.
How do I right click this one? As
There's a point.
okay. So yeah, sorry for the pause, but I have the module again. I redeployed it, and I'll run it again. So I just need to, in the first inference, we have a endpoint name, which will appear in Jumpstart. And you click on Jumpstart in your Jupyter Studio, SageMaker Studio. And below Jumpstart, you see deployments. On the left, I'll click on endpoints, and I see this Jumpstart endpoint. So I just need to select that and copy it. So we'll replace the endpoint name with the endpoint name that we copied. And we run this module, hopefully not deleting it. So we run this module, and just to recap, this module is we are we are invoking the SageMaker runtime and taking the input and converting it to run prompts against. Yeah. The endpoint, yeah, when we created that when we went to the Jumpstart console and invoked a new model, like selected a model. So now we'll be passing the prompt, and we'll see when we were talking about parameters. So we'll be passing initial parameters, which is like I mentioned top K. So it considers like 10 nearest data points and how many tokens or whether you want full text, etc. So I'll run this parameter. And I'll pass this prompt, which is like a weird prompt about peacocks. And I'll query the endpoint to run the prompt. So it says input text and with parameters, and it's generating a text based on that. The input text. So it's more like so it's more like it's created a chat bot where so Kai, what's the prompt here? Like we have passed a peacock information about peacocks, and then it created an output of like hello, I am delighted. Yeah, it's just random generated text. Yeah, it's random text. Yeah. 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 So we run the next prompt, we pass another, we do the same thing, and it generated a text about TCP sockets. So, and now once we, now we generated a random text. Now we'll be passing a sample research paper to demonstrate the summarization. So the sample research paper is about biomedical literature, and we'll be doing a text summarization for that. So we'll be reading the document. Let's see if we needed to import the document. Yeah, we have the document.txt. Absolute path, right? Yeah, that's what I was thinking. Yeah, yeah, you mean this, right? Does everybody see this error? Okay. And I hope I didn't delete anything, right? This is right after the hello everyone, my name is Dheeraj. This is the document. Yeah, Kai, I'm the only one who's seeing this error. Yeah, okay. Yeah. So then I'll just explain, even if it doesn't return an output, it should for you. So we'll be using like a LangChain, so open source software open source software library. So using which you can quickly build, tune, and deploy generative AI applications. And it's mainly used for complex ML interactions, and you don't need to write a lot of code. It provides like out of the box features to run Gen AI applications. So it can provide like prompt chaining, prompt templating. So what chaining is, uh, you will have like long text, right? Sometimes a prompt cannot handle, a model cannot handle a large text at once. So in a single call. So using a map reduce strategy, you can summarize like an entire document by breaking it down into like chunks, and then creating a chain of that using LangChain, and then summarizing them individually, these chunks, and combining them. So we'll install LangChain. And then we will import the relevant modules, and we'll break down the long document into chunks. It's not gonna run, this model is not gonna run for me, but let me know how, if it's not running for you. But please go ahead and keep running those, each of those code snippets. But I've ran this lab before, so I know what output is gonna generate. And then you need to do like the LangChain integration, define the things that need to be defined for running LangChain. And then you run a prompt, like a map prompt, right? A concise summary of this text in a few complete sentences. And you combine all of these summaries and present a final summary. So you have a combined prompt as well. And LangChain supports LLMs out of the box for a SageMaker endpoint, so you don't need to use Python SDK to run this. And you just run a function called load summarize chain. So what you will actually see when you run the outputs, you're gonna see like chunks of the document, right? And then it's like, it's running prompt for each, like summarize this part, summarize this part. And at the end, it's gonna combine the text and give you a combined summary of the large document. So it's creating like a summary of all the combined summaries. So we just saw like how you can use like an open source model or Llama to generate summarizations. in SageMaker because then it provides you a highly customizable way using open source LangChain to generate these summaries and out of the box pre-trained models to generate these. And everybody finish the final step, see like a summary of the document? Oh, you have a question? Okay, you see it. So now next will be, now we ran a model to generate a summary. Now we'll be running a model to generate a text to image through Stable Diffusion. And you'll see how within SageMaker itself, you can take the image. We'll also do image to image as well. There's an example for that as well. We will see. But it generates an output of the matplot of an image. You will see through the code, and it will generate an actual image. So you can generate like simple images to complex images using this pre-trained model. So in the first one, we will be just running an inference to using the Stable Diffusion model without fine-tuning. We'll just run a prompt and generate an image. So we will be using the second, in your Jumpstart folder itself, you see SageMaker Jumpstart image generation file, or it says Stable Diffusion inference Python or a Jupyter notebook. We'll run we'll deploy similar to the previous model, we'll deploy this model. And it installs. So now, once we have this model, we'll run the inference on a pre-trained model. So for that, we will create an object to run the inference on the endpoint. Oh, sorry, I skipped a few steps. So yeah, we will invoke the model with the model ID. We'll initialize, before that, we'll initialize SageMaker. So we'll be running this snippet, which gets you the execution role to run SageMaker. And then we will get the model ID. And we will invoke the model. And we will invoke that to the endpoint that we defined earlier. And now we'll create the inference. So we'll be passing on advanced, like it supports many advanced parameters, like you can put in text, width, height, or like image strength, etc. So n number of parameters. And we are importing the image format to generate the image so that we get the output as an image. So we are getting the image library, and we are just saying, generate a jaguar in the Amazon for rainforest, invoking the Stable Diffusion model with a few parameters. Yeah. Sure. Yeah, the session is 5 p.m. right? Okay. Okay. So everybody, we have pizza. So take a 15-minute break, and then we get back to, we only have one more lab left, but we'll see how the Jaguar is generated, for Jaguar image is generated.
We can continue 10-minute break. Why don't you take the piece?
Also, everyone, tonight shuttle service is there, okay? So whoever going to Baymont, we will provide the shuttle service, so no need to worry. But at the end of the session, I'll give you another announcement, okay? After the session ends, at the end of the day, maybe around 5:15, 5:20, are good? After.
So while we are enjoying pizza, we can simultaneously just see fun images generated by a image model. So feel free to run through the model. So yeah, let's settle in and we'll run through the prompt that says, generate me a picture of a jaguar. I mean, if you want to have fun, you can probably try changing the prompt to some other image as well. So once I run this prompt, and then we just want a code to generate, like the output is already generated, but the code will generate the output in the format of an image. So we'll just click on display image. And it takes some time to run that. And in the next section, we are also gonna try doing an image to image. So instead of a prompt, we'll pass an image format. So it can be like a string or a list of strings. Oh, yeah, see, it generated a jaguar. Let me know if anyone sees the majestic jaguar. Look at the image quality though. How many of you see the image or are there any errors? The next one is we are gonna specify parameters like what kind of image do we need, width, height, scale, and then as you can see, this is passed as an image, like the input is an image. So I run this input and we are passing a byte array of an image and converting it to a string prompt. So we'll be using a picture of a dog. So now this is the original image of the dog. It's a dog in a suit. And now we'll pass this image and a prompt. So it has two contexts. It has an actual image and a prompt. And based on that image and prompt, we are saying like dog in embroidery. So based on like the source image, it generated an image with the same dog in embroidery just through a prompt. And as you can see with the compute of SageMaker, it took like less than a minute to generate this image. There is one more fun where we talk about prompt engineering, like how descriptive you can be, the better image it can generate. So writing a good prompt is an art. So sometimes if you like just write a short prompt, you can't predict what's the image gonna be. So as much creative as you are, the better image you can get. So you can like say creative things like, hey, generate an image like let's closer to a painting of a Pablo Picasso or Rembrandt. And there's jobs out there where they hire people from prompt engineering. I don't know why, but there's just writing creative text. So I run this prompt, which says like something, wow, a beautiful illustration of a young Cybertronic. Too much creative, like Hyderabadi American women. Yeah, I don't want to go through that. And we'll wait for it to. So you can see there's like the thing about prompt engineering in terms of descriptive, you can like give like specify specific features to get more specific outputs, like how should be the face, how should be what kind of jewelry, etc. And how more descriptive you are, the more detailed. I mean, it's quite an impressive image that it generated based on that. And I think probably each one of you, did you all get the same image or a different image in this scenario? Same image? Okay. I think it was about 2 images. So yeah, it's portrait of glass window, etc. So it generated multiple, also of Nicolas Cage. So is everybody seeing images, or is it doing something weird for you? Cool. So now in the next lab, we'll be fine-tuning the model. So right now we are just running inferences, but we'll be fine-tuning this stable diffusion model. So we'll be introducing it instead of a pre-trained model, we will be training the model with more data points and create our own version of a model. For example, in this model, we'll be training it to remove noise, which what I talked about earlier about the prior preservation technique. We'll be using that to train this model. So again, we'll initialize. And this is this is inside the Jupyter notebook file, which says stable diffusion fine tune. And we'll be feeding it a custom data set to train this model. So we'll be using like a script. We already have a script that's loaded to fine tune this model. And the model returned by fine tuning we need to deploy it again for inference, and which is like a new version of the model. So the images are more like what I talked about, like images of dogs. There's a class data directory of multiple dogs breeds, and then there's specific directory for poodles. I don't know whether it's poodles, but there's a specific dog. Oh, it's a Doppler dog. And then we have a class image of generic dogs. So we'll create a training artifact. We talked about artifacts in the IoT labs. So this will be similar in the sense we will have a Docker container, we'll have the training algorithm and the pre-trained base model. And we'll create an artifact with the code, with the script, fine-tuning script, and redeploy the model here. So we are using like a instance type which has a GPU memory, which is MLP3 2x large. Then we'll set training parameters, which includes like the S3 bucket where we have the dog images. And we'll also use hyperparameters. So we are passing those hyperparameters in the form of a Python dictionary. So you can see when it generates the output, you can see the list of hyperparameters that we are passing. So we can take a look at the data set, which is of the dogs. and we'll start training the model. We'll run the inference. Now we have the fine-tuned model. So we deploy it in this code, and instead of the earlier pre-trained version, we have this new version based on just dog images, and we'll run this model. Any questions so far? And now we'll just write code to display the output of the image. And we say the prompt is a photo of a Doppler dog with a hat. But the difference between here is it's not going to just use the pre-trained model to generate a Doppler dog with a hat. You won't, it's very minute to identify, but you will see more of a clear picture of a Doppler dog because it's using the technique that I said, that it's differentiating from other dogs. And that's how the model is trained right now. So let's see the image generated. It takes some time to deploy and run the inference model and train the model. So it'll take a few minutes. I think we have like around 30 minutes. We can do one more lab for the MLOps, which Kai will be leading while we wait for the output. So yeah, we'll wait for Kai. But yeah, I hope this lab was a bit more fun because it was like image generation, and images are always fun. And AI generated images are, in my opinion, more fun. But we are waiting on the image, but while it takes time, we can probably start the next lab. Yeah.
Meanwhile, we'll get back to the boring stuff.
Boring but important.
Boring but important. Thank you, Archie. So I was taking a look at Jumpstart a little more closely because there are a wealth of models in there. But unfortunately, in these lab accounts, you're probably not going to get the instance sizes that you need to go launch some of those other fun ones. But you can certainly try. A lot of them just require instances that just are not whitelisted for this particular environment. But you might be able to find some of the smaller ones, the small Meta Llama models. It's just Jumpstart's pretty stinking cool for some quick button deploy large scale LLMs. I also looked to see whether we had Bedrock in the environment, and we don't either. And that's the API where we could do some fun stuff. So it is back to the dryer. Who was asking for ML Flow? This table here. Okay, yeah, let's jump to it. And my thought there is let's find the notebook and we can run through it. And that'll I'm just going to kick it off from start to end. That should populate some experiments. Do you have a particular challenge or use case for ML Flow, or just general curiosity? General curiosity. Okay, yeah, let's take a look. I'm not super deep in it myself, but the nice thing is that it's essentially open source and it's been integrated into SageMaker, which makes it really easy to access. I just have dirty glasses after pizza. Okay, so let's see where that's at. And for those still following along, I'm going to backtrack to the Amazon SageMaker Immersion Day folder. My font's just really small on my screen, but I think it looks fine up there. And there should be a ML Ops folder. We're going to go to tracking. ML Flow tracking. So I think this is an end-to-end notebook. So I'm going to go ahead and launch it, and then we can go, well, that's thinking. And I know the first part of this notebook really just goes to say, hey, do I have an ML Flow environment in my environment? And we do. So part of the CloudFormation stack actually stood up our ML Flow server. So looking at SageMaker Studio, again, we have our Jupyter Labs, we have RStudio, we have a code editor, and we have Canvas. And again, Canvas is pretty neat. We're just not getting into that today. That's our no-code ML experience, but we can actually go into ML flow directly. So right here, again, when we bootstrap these accounts, we already have an ML tracking server, but we could create a new one, and that looks good to go. But once our notebook finishes, we'll then actually have our results here in the ML Flow server. So again, think of ML Flow as an open source server and framework, but we've just incorporated it into SageMaker. You can certainly go run and download, and many customers do, their own ML Flow environment if you want, but we have a quick, easy button, push button way to get that done for you. So the things to know is once you've trained a model, and we'll have some stuff in here in a little bit through are you running the notebook also, or, okay, just looking online here, okay. So we'll have some data in here. So the things to know is that once you have a model run through and you like how it looks, then what we can do is then we can actually register the model, and that would put itself into a model registry, so then we can allow other people to come pull that as they need to, and then we can also just push button deploy. So that's really the purpose to it. So let's see where this is at. So again, we're seeing some of the, and one way to navigate a notebook, I tried this earlier, but some of these don't all have collapse on them. Just try to figure out, just try to understand what's shaping up here. We're just going to collapse our data prep. And kind of skipping over a lot of how this is actually being built. So we're actually training up a little job. Okay. So once we have the training finished, then we can actually run some inference and look to see how we incorporate the ML flow experience. So any questions from our cheat session while we wait for our ML flow experiments to be populated? More Q&A for myself or those in the back? Yeah. What I was going to do is actually just ask some AI on this one. So the question was that there's actually a limitation to ML flow for the artifact download side. So let's just see if we can get any explanation on it. But invariably, you do hit constraints on services, and it is something to be aware of when you're working with, say, SageMaker endpoints or compute sizes. It's just invariable. You might hit a file format kind of limit. And this is just an internal chatbot that we use. So we're just looking for an answer. Yeah, so that is a limitation to MLflow specifically, but I think this is a pretty good, this is Claude Sonnet 4.5 giving a suggestion. Always trust but verify, right? For any kind of AI response. But I think the solution at the bottom is a pretty good one. Just feed your artifacts to S3, right? So you can still get your metrics and all that stuff, but to use MLflow as your actual model registry for artifacts, there is a hard limit. Yeah, I didn't necessarily get a detailed answer as to why, what's the technicality there, but just ship your model to SageMaker artifacts, which is going to be there anyways if you trained it. Okay, so where did we get to? Training job's good. Okay, so we're actually registering our model with MLflow, but we should have some experiment metrics. So again, here's what we can do with it then. You can run multiple iterations, multiple jobs. It's going to have our model metrics. These metrics are a little bit canned, if you may, just very simple passes. It's going to tell us if we had any system metrics, as well as the artifacts. Very detailed on what our training scripts were, any of the inputs, and it should also give us, there's our model path. So to your question again, it's the direct download from MLflow's 200 megabytes, but you still have a model and the artifacts in S3, so you just go through S3 to download those. Yeah. I'm just trying to think of a quick way where you could actually get that out of the experiments. And what the rest of this demonstration, when it completes, is once we actually have a model that we like, then we'll actually be able to ship it out. We just don't have the actual model created yet. Give it a little bit more time. So good question there. What are the questions? They can be broad. Gen AI. All right, doing good then. And thank you for the pizza, it was very good. The question there was if you're fine. The question there is if you're fine-tuning, say, our stable diffusion, what size data set? And that's going to vary a little bit, as everything. There's a bit of it depends. What is your fine-tuning technique? What are we doing? So if we're doing, LoRa, PEFT type of things, just a few hundred, 500, well-curated data set, you'll start to see some influence. Maybe 1,000 is going to be better. But I think typically between the 500 and a few thousand for a LoRa type, low-rank adapters, especially around images, you're going to start to see some input there. And again, then you need to start experimenting. At what point does it start to fall off? Or do you start to overfit, et cetera? And that holds true for text as well. about there in those ranges. Now, if you're looking to do more continuous pre-training or get to the lower layers, then you're going to need more data because you're simply just more adapters. Yeah. Computer vision models, sometimes you can be talking tens of thousands of images. Well, if you're talking more supervised learning, right? Other good questions? Somebody must have one. All right. Yeah, and are you thinking like almost in a form of jailbreaking? Yeah. Yeah, I don't know, to be honest. Anybody know the LLM architecture well enough to know how image poisoning works? Okay, I honestly don't know. We could ask. I got a model. You think I'm joking? Let's do it. I think it's a great question. This is how I spend my day. How do you guys? It used to be Google. Now I'm going to go probably ask Claude. This is just an internal tool we have good access to, but. Because I think it's very relevant to this conference too, because in a way this comes down to security. How can I jailbreak these things? How can I make it do something I don't want it to do, or the designers doesn't want it to do? So there's the security of AI, there's doing security with AI. Pretty fascinating. So tell us how it works. So it's a vector attack. So I think this is a good one too. Will cause it to not use its internal guardrails that were built in, essentially confuse it. And this might be a little bit of a cop-out, and I think there is a better technical answer, but when you really think about it, not everybody understands how these outputs come out of models. So to me, a bit of these kind of poisoning and jailbreaking, it's basically throwing spaghetti at the wall until you introduce, again, some sort of confusion or something that those layers in the model don't know how to process. So what it comes out with is just essentially garbage, right? I don't think you can often get predictive results. If you do the same thing over and over again, yeah, you can, but can you be scientific in that approach? I don't know. If you change some other pixels in that sample image that you're putting in to confuse it, are you going to get a completely different output? Probably, yeah. So good question, I like it, yeah. How many of you all here just spend your day asking a chatbot of some sort for answers versus Googling? I think it's a fascinating change in user behavior. I admitted it, you admit it, yeah, okay, yeah. I think it's pretty cool. Just trust but verify, right? Always take another look, get another source. Ideal, it'll cite its source. Okay, so this is still cranking away at the ML flow, but I do want to talk a little bit about pipelines, and we don't necessarily need to get into it from a code perspective. People are kind of starting to fall off, had some pizza, but you do need to start thinking about doing things at scale. Again, we're talking to a project over here that's doing some cool stuff. I know we had a computer vision project off of drones, was really interesting, but end of the day, it's how do you build an ML ops pipeline so that you can do this in repeated, controlled fashion. So we should show this. Let's kick off another notebook. I think this is pretty cool. Go back to ML ops. I think the pipeline build is one of the quicker notebooks. So within SageMaker, we can actually go into, within Studio, we can actually go into pipelines. And it provides a graph interface where you can build out your flows. Okay, we can drag that. Let's actually go into pipelines. Okay, we do have to wait. This is going to build a pipeline for us. But within pipelines itself, you can do a bit of drag and drop. So let's create a new visual editor. And you'll recognize some of these things on the left-hand side, right? These are components or concepts that we've already worked with. Say we want to train a model, and we've created a notebook script that we really like, then we can plug that in here. And in a moment, we're going to have one that's all built for us. Say we have a our own notebook with a piece of code that we want to work before we train our model. So then we can connect these two. And here we could define a notebook that we already have. Remember, we assigned instances to those things that we're running, so we can define the compute for them. And then we can begin to stitch these things together. And again, when this completes for us, we're going to have a complete version of what a pipeline would look like, and it will actually start to process for us. So where are we at? But that's, again, when you start going back to where we started with the define our business challenge, what's our problem? Let's go gather the data. We might have to do some ETL. Let's extract the data, let's transform the data, and let's bring it to our model, okay? Once we have our data prepped, then we're going to pass it on to the actual model training. And think of those as individual steps. Everything that we've been doing today has been in a single notebook, but can you really distill those to individual components and make that more modular and then circle through the actual training and feedback loops? And it's fun to see once it gets going, but where are we stuck? Okay, so we should actually have a pipeline at this point. So I'm going to go back to SageMaker Studio. Let's see if we don't have to actually build one from scratch. Okay, here's our abalone. Okay, so this is actually stitched together 4 different notebooks. They're in the repo, so we can see the individual code and the individual steps. So we have an evaluation function, we have a pre-pros function, we have our register, and we have our train. They're not in order on this side. Yeah, here we can see them in action. So the pre-processing step is actually doing that right now. It's taking the data set that we provided it, and it's going to process it. If everything checks out there for us, then it's going to move it on to the train phase. So it's going to happen for us automatically. And then you can create that event-driven architecture, right? So every time your data changes, then you can trigger this pipeline. It'll just happen for you automatically. If you need to come in and revise the code, you can certainly do that with versioning, et cetera. So it's a good way to think about it, especially when you guys are collecting data and whatnot. How can we just, okay, we have new data, but we don't want to have to go back in there and manually execute things. Just drop your stuff in an X3 bucket. They have a thing called S3 events that would just go ahead and then launch the whole workflow end to end because you had your notebook set up in there that are just going to do what you want it to do. And you could have just a single notebook in here. You know, it could just be a single step pipeline, but how do I make this event driven versus every time coming in and having to poke the buttons? So I think we're getting pretty close to wrapping up. What do you all say? Yeah? Yeah, good day? Long day? Challenging day? Yeah? I got it like this on the good day? Okay. I got something for you though. And we gave away all the swag. Is that true, Lucas? We give away all the swag back there? We got pens. Okay. But all the cool stuff's given away? Okay. But let's wrap up on this. And from the AWS side, we do say thank you. Here's your chance for feedback. So zap that. Oh, yeah.
And I want to recognize the AWS team, so could you please come forward so we could give you some nice plaques? Derek, are you going to take some pictures? Kai? Archit? Archit, okay. Varun? Yeah. You guys are awesome. Thank you for spending the whole day at UND for us. This has been a good experience for our students, and I appreciate for being here. Hopefully, we can work with you as we go along in future. And appreciate. Please take the survey and provide the feedback to them as well as us to see. And maybe I'm interested to know what are the other workshops that you're interested, so we can able to host it either online or next year, right? We want to make sure it's a student-oriented workshops. So. With that, I also want to thank our IT team at the backside. Matt, do you want to come forward? I have a plaque for you. Without all the technology, without your help, we couldn't have done this. So I appreciate for. So this concludes our, second day, right? And we still have third day if you want to join. It's a lot of online paper presentations happening tomorrow. And okay, the shuttle bus is here already? Oh, you're going to, okay. So they say that the shuttle will be ready in 10 minutes. Okay, it's 5 o'clock. Okay, so the Baymont Hotel. So good luck. I'll see you tomorrow or next year, depending on what you're planning. Thank you.